we'll be able to finish all sessions today at the planned time. So I hope that the presenters will take that into account. For now, I'm going to remove my face mask because some of you are seeing me for the first time. And it's important that you also know my face so that when we meet again after COVID-19, you will be able to recognize me. So my name is François Sengiumba. I am the chair of the committee that is organizing this conference. And I'm being supported by my colleagues here at Ines. It's a team of 14 people who have been working hard to make sure that this event is successful. So it is going to be a hybrid conference. That means we have people presenting physically, people who are sitting here, and people who will be presenting from across the world. We will have people presenting from Europe, people presenting from across the African continent. Virtually, those people who were not able to attend physically due to the constraints associated with COVID-19. So everything has been well established, and I hope that both versions will be well managed. The participants involve people from across the African continent and beyond. As I said, some of them will be presenting physically, and others will be presenting virtually. The theme of the conference is repositioning civil engineering education for sustainable development. What does it mean? All of you are either university professors or university students. So you know the mission of a university. The mission of every university is teaching, research, and community engagement. So at university, we do not only teach. In addition to teaching, we also do scientific research. And the research that we do must be contributing to the enhancement of the quality of teaching and learning, with the student at the center of everything that we do. So the conference is a research conference. We will have many people presenting cutting-edge research findings. So so we will have many people presenting cutting-edge research findings, and at the end of every session there will be an open discussion where every participant will be given an opportunity to contribute ideas towards reshaping civil engineering education for sustainable development. So in addition to that, as we all know, civil engineering is an area that has got a definite potential to boost the economy, but if well taught. Unfortunately, if you look at how civil engineering education and education in other areas, by the way, now we are focusing on civil engineering education, but the same applies to other areas. If you look at how we teach in sub-Saharan Africa, we mostly focus on the theoretical component, which does not help much. So, because we want our students to have strengthened practical skills by the time they graduate, so that they will be able to successfully compete on the labor market. So by the time they graduate, if we teach them well, by equipping them with the practical knowledge, not only theoretical knowledge, by making sure that we link what we teach in class with what is needed by the labor market, by the industry, then our students will be able to successfully compete after getting their degrees. So the conference is also going to be an opportunity for us to discuss that and come up with the measures, with strategies to address all those gaps. So that is why the theme of this conference is repositioning civil engineering education for sustainable development. So we are trying to come up with a way of reshaping how we teach our students in civil engineering so that we give them what the labor market needs. So I hope that this is enough as an introduction. I will be moderating the sessions, today's sessions until lunchtime, and I will be working with the other two colleagues who will be helping me to moderate other sessions in the afternoon and tomorrow. So now I wanted to invite our Vice Chancellor to first allow for players so that, because we also need, of course, everything is well organized. We are confident that everything will go well, but we also need the blessings of God. So we wanted to, our Vice Chancellor to allow us to play so that God will also help us to make sure that everything goes well. Then after the players, the VC may carry on with the opening remarks. Thank you very much.
In the name of the Father, and of the Son, and of the Holy Spirit. God our Father, thank you for your love. We thank you that you care for us. We thank you that you created us in your image so that we may be caretakers of this world using our intellect and will. We thank you that you have brought us together to think, to reason, to share knowledge in order to better serve this world. Bless us, bless our minds, bless the guests, that everything we do may be under the control of your hand, through Christ our Lord. Amen. In the name of Father, Son, and Holy Spirit. Distinguished ladies and gentlemen, all protocol observed, it is my pleasure and honor to welcome you to Ines Ruhengeri, most especially to welcome you to the International Conference on Civil Engineering Education, Rwanda 2021, with the theme of repositioning civil engineering education for sustainable development. This workshop is in the framework of the project entitled Strengthening Academic Industry Linkage and Research Space in the Area of Civil Engineering for Food Security in Sub-Saharan Africa, funded by the Royal Academy of Engineering. The project brought together 5 universities teaching civil engineering, such as Aberdeen University in UK, Badani University in Nigeria, Catholic University of Cameroon, University of Botswana, and Ines Ruhengeri, Rwanda. The program aims at enabling the higher education system in Sub-Saharan Africa to produce engineers with skills and knowledge required to meet the needs of industry and to tackle local challenges. Several activities have taken place, including civil engineering, curriculum review and development, linkage between academia and industry through staff industry attachment, conferences, just to mention a few. Due to COVID-19 pandemic, other international conferences which took place were held virtually. Today, we are very happy to host the first international conference, hopefully not the last, held in a physical mode, or let's say in a blended mode by choice, not by restriction. The objective of the conference is to bring together a number of higher education institutions and industries in sub-Saharan Africa and beyond to discuss the latest research findings that contribute to the enhancement of the quality of teaching and learning civil engineering. The conference is expected to be a platform for researchers across the African continent and beyond to discuss the challenges and opportunities in civil engineering with the ultimate goal to reposition the education in this area in line with the UN SDG 4 on quality education. The conference is also expected to be an opportunity for researchers to build new partnerships for sustainable development in line with the UN SDG 17. As I welcome you to the conference, let me take this opportunity to brief you about the host institution, Ines Ruhengeri. This university is only 18 years old, but has made it to take giant steps thanks to the passion and determination of its founders, but also to the conducive environment created by the government of Rwanda, geared to building a resilient nation. Created in 2003, Ines Ruhengeri came as part of the efforts to reconstruct the Rwandan society, which was damaged, seriously damaged, by the tragic genocide against Tutsi and the wars. Ines Ruhengeri came in to build signs of hope, to contribute to unity and reconciliation, and to contribute to sustainable development. Founded on the Catholic values, Ines Ruhengeri is known for its choice to becoming a University of Applied Sciences, a decision made in 2010 with the aim to bridging the gaps between academic products, graduates, and the labor market needs. Having adopted the concept of a University of Applied Sciences implies choosing to be a practical university, which makes a valuable balance between theory and practice during the teaching and learning, but also taps from the real-life problems of the society to build its teaching and research agenda. The concept of University of Applied Sciences applies to both hard and soft sciences, though Ines Ruhengeri has a strong bias to hard sciences. The choice has involved a strong linkage with the industry, and by industry, we do not understand processing or manufacturing, we understand a working setup. It has also involved partnership with local, regional, and international professional bodies, and has led to development of strong network among teaching and research institutions across the world. Thanks to SAIC project, a lot has been achieved, beginning with the network developed among project partners, and I would like to take this opportunity to invite all the participants to take advantage of this international conference to fasten the already existing ties amongst partner institutions through individual networking. As I conclude my remarks, I would like to thank the organizing team led by Dr. Francois Nsengiyumva for creating this platform of sharing knowledge through different presentations and discussions that are to take place during the 3 days. To the guests, most especially those who have come from outside Rwanda, I wish you to enjoy the land of thousand hills, the home of the rare mountain gorillas, which may be following the conference through the windows, since they are the closest neighbors of Ines Ruhengeri. Enjoy the conference and feel at home.
Thank you, VC, for excellent remarks, which put us in a position to officially start the sessions planned in this conference. So the first session that we are going to begin with is going to be delivered by Dr. Emmanuel Rukundo, who I would like to invite here. Please, may you come here? Come closer. Have a seat a little bit. Have a seat, have a seat. So that I want to introduce you first before you can start. So Dr. Emmanuel Rukundo is a Rwandan citizen, lecturer and head of the Department of Civil Engineering of Ines Ruhengeri. His research interests are mainly in the area of water resource engineering, and he has published many articles in sciences index journals in this area. He will present physically a research work entitled Dominant Influencing Factors of Groundwater Recharge Spatial Patterns at Catchment Scale. So Dr. Emmanuel Rukundo is going to begin the session. He will be given 45 minutes. The session is given 45 minutes, but if you can maybe use 30 minutes so that there will be open discussion for maybe 10 minutes or 15, that would be okay. You can start, please. Thank you very much.
I think I would like to stand here. Good morning. As Dr. Francois said, I'm by Dr. Rukundo Emmanuel, and I'm here to present one of my research paper. It was published under the support of the government of Turkey, where I did my PhD, and also the Institution of Research of Germany. So we conduct this research in the Mediterranean catchment, where we had the problem of the groundwater recharge, the quantification, to quantify the value of the groundwater from the precipitation. So the title is the dominant influencing factors of the groundwater recharge, spatial patterns at the catchment scale. So So the IT team, okay, it's working. So here there are outlines. So I'm going to focus on the motivation, what has motivated us to conduct this research, the objectives, and the methods that can accurately estimate the recharge, and the recharge controlling factors. And then finally, I will discuss with the results and conclusions. Okay, so for the motivation, First of all, the groundwater supply. 40% of the world's population depend on the groundwater supply, and 50% of global food production depends also on that comes from the irrigation, depends on the groundwater. And in the case study that is called the Elgin catchment, there is a population of 1 million, around 1 million, that depend on the groundwater supply. And around 2,500 industry also that depending on the groundwater. And even most of the activities are agricultural activities, where 73% of these activities depend on the groundwater. So therefore, that was the motivation, so that to manage the groundwater and to make it more sustainable, it was urgent to quantify the recharge that replenish the groundwater aquifers. And the objective that we have were first to create a GIS input database made up of the climate data, the land use, the soil, the geology, data in topography, and then determine the distributed water balance, including the groundwater recharge. And then later, find the dominant influencing factor of this recharge so that we can control in the catchment scale. In the materials and methods, this was the case study. As I mentioned before, it is Elgin catchment is one of the Mediterranean catchments. In this catchment, it is located in the northwest of the Turkey, and it is the most catchment where the groundwater is at high level of exploitation. And this catchment covers 1.4% of the area of the whole country, and it's cover around 11 kilometers squared, 11,000, and its topography range from 2.3 to 1,000 meter above the sea level. So, I don't know if the IT can connect this with their. Oh, okay, I see it's. So in the climate data, we use different data, but if you want to quantify the groundwater, the first input to the model is the climate data. So we have used the daily data of precipitation and the actual evapotranspiration. And for the day we used that was the catchment. We had around 10 sub-catchments, but where we have the stations with the full data, it was for precipitation we used 5 catchments, and for temperature that will help to find the evapotranspiration. We had 6 sub-catchment stations that we used, and we found that within the catchment, the precipitation is around the average 600 millimeter a year, and with actual evapotranspiration, the grass evapotranspiration, it is around of 1,000 millimeter a year. And also we use the land use data. As you know, we cannot quantify the water balance quantity without the land use data. So here, the land use data, as it can be seen on screen, it is by around 54% of this land use is non-irrigated arable land, and we have also the 80% of the permanent irrigated land. We have agricultural land, around 7% of the whole area. We have the urban land also, which is 1.7. And also we have the area there is a marshland where there is 2.6 of rice field, and also there is the forest in the north that covers 6%. So this is about the land use data that we use because this model we use, we calculate the water balance component quantity in each grid of this land use for 30 meters. And we used also the soil data. The soil data have been used mainly to know the moisture content, the field capacity, and even the wilting point of the water in the soil. Why? Because we need to extract from the groundwater recharge. We need to first to extract from the precipitation the amount of the actual evapotranspiration. So the soil data was very useful for this research. And as you can see on screen, we have the different types of the soil. We have the brown forest soil, we have alluvial soil that cover 9%, but mainly the main soil is brown soil without rim that covers at 4% of the catchment. So we use also another main data that is in the catchment. This is the topographic data, the aspect and slope. These have been used to collect the actual evapotranspiration depending on how the grid of the land are, either if they are in the east, in the north, if there is a slope. So this has helped to find the actual evapotranspiration. And this, for the next then, I want to present the model that we developed and that we used for this study. So the model here, presented here on your screen, sorry. So it is a groundwater model. It's called M-Grower. Groundwater model that can be estimated the groundwater recharge for the big area, like a big catchment for entire country. And this model is very useful when you want to take decisions for management of the groundwater. So what we do, we feed the model with the first column that you see. We feed the model with the precipitation, the grass reference evapotranspiration data, and even the data related to the land use, the topography, the depth to the groundwater table, and even the other data related to the hydrological units and hydraulic permeability. And the model, first, in the model, we calculate the total runoff and the actual evapotranspiration. So from the total runoff, then we separate from the groundwater recharge and then the direct runoff. So this is the model that we created, and by using the code, and can be learned by using the Python and the R codes. And then in the model, what we have here, we use different equations to find to balance the water components. First one, that's the equation that you see in front of you is the water balance equation, where the precipitation is a function of the precipitation is divided plus the irrigation water. It can be divided into the actual evapotranspiration, the total runoff, and the storage of the area. And we use the ET by using the Montaigne, that equation present there, where we have the grass reference evapotranspiration. We have the CLOP, the KLN is the CLOP, is the CLOP coefficient. We used also we call the function of the slope or topographic function, and also the function of the storage. And this function of storage can be depend on the land use cover that we have. So those are the equations that we use in the model to find, especially to find the height, please. Okay. So those are the equations that have been used in this model. Okay. So here in your screen, So from the water balance, first we calculate the actual evapotranspiration, and from in actual evapotranspiration, we determine the function of topography by using this question. These have been used using GIS tool, and then depending on the cover of the land, where if the land is covered by the vegetation, we use the function of the moisture content. If it is impervious area, it can vary between 0 and 1. We use this function, and if this the free surface body, the function of storage is 1. And these questions have been included into the model, but the purpose was first to find the actual evapotranspiration that will be removed from the rain of the catchment, in the catchment. So, next please, because okay. So here we have the model that we use. The model we determined, it takes, this is an example, it took higher, for each grid, like 10 meters. The dam we used in that case was 10 meters. For 10 to 10 meters, it takes 5 layers, like we have here. And for each 5 layers, so for each 5 layers, the layer has 3 decimeter for each and every one. So we had to determine the component for each layer. First of all, we determine the precipitation and the gas difference evapotranspiration. Then we put in the model. And secondly, we calculate the actual evapotranspiration depending on the moisture and rooting depth as in the model. And those are the equations that we use. And thirdly, we calculate the percolated water in the model, in the root zone. And finally, the percolated part in the model, it was taken as the total runoff that will be separated from the groundwater recharge and also from the direct runoff. So this is how the model, we constructed how it is. And then, in the separation method, this is the separation tool that we used. Depending on the site characteristics, depending on the logs that are there, we use the principle of base flow index. And this principle, it can divide the total runoff into 2 components. One is the groundwater recharge, another one is the direct runoff. So this was included, but the general formula that can be, it's presented there, is the total runoff is equal to the BFI. BFI is the base flow index times the total runoff, and this component is the discharge runoff, and then the other component, the remaining part, is the direct runoff. So this is how the model was constructed, and then let's go to the how we feed the model then. So we feed the model by the gas difference evapotranspiration. We use the Hargreaves question, and this question depends on the temperature, the maximum, the extreme temperature, the radiation of the surface of the crop, and also the 3 coefficients. And this 3 coefficients depend on the location, and by using this research, the different research, we extract those coefficients, then we find the gas difference evapotranspiration for the model. And also for the base flow index, it was calculated based on the existing runoff hydrographs, base flow and direct runoff, and the quotient of them is the base flow index. And this was used for calibrating the model in this way, as presented on the screen. So this is how we calibrated the model. So in this figure, what we did, it was first to calculate the component of the water balance for each grid. And for each grid, we make the average for the whole area. And then, for the whole area, for the whole catchment, we take the average. And then, we compare from the existing data, the existing records of the hydrograph, the base flow hydrograph, and even the direct hydrograph. And we compare by using the Nash script index, and this index was generally averaged on the catchment level. So this is about the calibration to have the real results that we can trust. So for the other objective was to find the controlling factors of the groundwater recharge at the catchment level. So we use the principal component analysis. This is an old method that can use to, when you have the big data set, you can remove those who cannot represent the parameter and only take those who can present at the high average, the parameter in the catchment. So this is the principal component analysis we have used, where we had around 10 catchment with different variables of the soil, of the land use, and of the climate, and also for the topography. So this, the data we abbreviated here, but those are the same as we saw in the map of the data of land use, soil, and climate and topography. And then here I want to present the results from this research. So the first result was the actual evapotranspiration. For the whole map, the target of this model, groundwater balance, it was to know the average water balance component for each grid, even for the values for each area. And remember, the grid is 10 meters. So we found that the high actual evapotranspiration was found in the north part, where it is ranged in 400 to 450. Why? Because we find that it's covered by the forest, and the forest use a lot of water for actual evapotranspiration. And also for urban area, we find that it is less. The actual evapotranspiration is around less than 300 millimeters a year. And why? Because most of the water is a part of the runoff. And also we found that in the lowland, the actual evapotranspiration vary between 350 to 400 millimeters a year. And then we found the average for the whole catchment is around 450 millimeters a year for this catchment. And then we continue with the total runoff result. Please, the IT team. Okay, thank you. So for the total runoff, we find that also it can be seen in the map, but those are it has the values for each grid. So we find it was generally in the north, where we find there are forests. We find that there is a decrease in this zone of the high altitude located in the north part of the catchment. While we have the forest, the actual evapotranspiration is very high. So we found that the total runoff is less than 150 millimeters a year. And then we find also for the urbanized area, it displays the high total runoff between 350 to 400 millimeters a year. And for the close area, the whole area of the catchment, it is around 200 millimeters a year. So this is the result of the runoff, the total runoff in the catchment. So, and also we have for the direct, remember the total runoff was split into the direct runoff and groundwater recharge. So we found that the direct runoff decreases in the high altitude in the north, where we have the forests. And also we found that in the alluvial soil, we have the lowest part, because the main part is infiltrating. And then in the urbanized area is where we found the maximum values between 200 and 300 millimeters a year. And And the average for the whole catchment, it was 85 millimeter a year for the whole catchment. And also we found for the recharge, this is the key of the research. The target was here. We found that the recharge, it is in 3 zones, the high, the moderate, and the low, depending, you can see in the map. And we found that the moderate zone is range between 200 and 100 and 200 millimeter a year. And for the alluvial plain is where we found the maximum recharge in the country, in the catchment. And the average was 95% millimeter a year of the catchment. And these are the results of the recharge, monthly groundwater recharge. We saw that it starts from the, this is the hydrological year from October to September. We found that it starts from the October to the end of April, because in April is where they start the agriculture activities, where most of the water is taken in actual evapotranspiration. So, and in water, we found also in the water balance component. Sorry. So please, the IT can support the, oh, okay, the next, okay. So here we have for the water balance component, it was shown depending on the type of the land use, because we want to see the factor that controlling the increase or decrease of the groundwater recharge. So it was found that in the forests, the costs that are there, we have the actual evapotranspiration dominates. The colors can be shown there, and it was seen that in the agriculture grid cell, we have the ET control the other water budget also, and also we found that in the urban area, we found that the ET is less, and also we have more runoff. This is the water balance, the groundwater recharge, depending on the soil now. So with different type of the soil, we find that the maximum one is in alluvial soil, with the greatest rate of the recharge, and also we found that in the urban area, we have less values. And here we have the calibration of the model. This model was validated, calibrated and validated, and those are the results of the validation, where for the total runoff, the coefficient was around 0.94, which means the model can predict the reality at 94%, but for the groundwater recharge, it was around 76%. Why? Because we have more parameters to include related to geology. And for principal component analysis, we find that here we have different results. Sorry. We find that the alluvial soil is composed mainly by the sand with the high hydraulic conductivity, and it is positively correlated with the groundwater recharge, and due to the high hydraulic conductivity, and therefore we have more percolation, we have more groundwater recharge. And also for the brown forest soil without lime negatively correlate with the recharge. Why? Because there are fraction of clay soil that possess, and this has the low conductivity of the groundwater recharge. And we found that for the forest biomass, the intensity of actual evapotranspiration reduced. Why? Because the direct runoff reduce the direct runoff, and therefore it negatively correlates with the recharge. And here we have another result of the principal component analysis, where we have the high eigenvalue. It means it's a component where we have more presentation. I mean, where the parameters selected here present the groundwater recharge variability in the catchment. And we found that that the variability, the principal component represents 65% of the whole variability of the recharge. And for the second principal component, It's around 83. So we consider the two components, and we found that the variables that are here in front of us are the one that are affect a lot the water recharge in the catchment. So therefore, we conclude that here is the conclusion. We found that this catchment was really highly exposed to the high level of groundwater exploitation due to the industry and agricultural activity, which means there was a need of the management of the groundwater recharge. And also we found that in water balance model, the actual evapotranspiration from the shallow groundwater can be significant, especially when groundwater dependent wetland, which means the position of the groundwater table should be taken into account when there is a capillary rise. And another conclusion, we say that the spatial groundwater recharge is improperly considered in the modeling of the groundwater. So therefore, there is a need of appropriate estimate of recharge from the water balance model that can be used as the upper boundary of the groundwater flow models. Because in groundwater flow models, normally it's hard to find this upper layer of the recharge. So we can couple those two models and so that they can work together. And the last one, it was that in the agreement of the principal component analysis, it can be concluded that the spatial patterns of the recharge are influenced in order of significance of the vegetation land use, the soil group types, and the climate data. So those are the main factors that are influencing the groundwater recharge, and that can be taken into account when you are managing the groundwater recharge. So those are the results of our work, and I thank you so much for your kind attention.
Thank you very much, Dr. Kund, for your excellent presentation. And I now welcome, it is now time for open discussion. I welcome comments and questions from participants. Participants include people who are attending virtually. So I'm wondering if people who are not here will be able to ask questions. IT experts, how do I make sure that people are following virtually? Will they be able to ask questions? I want to make sure that people who are in the UK, people who are in Botswana are following, and that they will be able to ask questions and contribute ideas. No, I first want to check whether people are following virtually. How do I ensure that people who are to who we have sent a Zoom link are following virtually? How do I check that? Okay, check and let me know, because we need participation from everyone, physically and virtually. So in the meantime, to save time, so let us welcome contribution from people who are here, who are attending physically. Yes, Farah?
Maybe you can use a microphone because...
Thank you, Dr. Rukondo, for that presentation. I want to find out if there are limitations for the model you used. And could you have used other models? Did you try other models, or that was the best model that could be used to solve this problem? Thank you.
Yeah, thank you so much. Actually, this is the model that was developed after analyzing that to quantify the groundwater recharge is the hardest part. Most of the estimation that we have are not accurate. They take from the groundwater balance question, but they cannot do it on the specific area. Like the model we use, we count the groundwater recharge for 10 meters, 10 meters. So there, if you have that scale, you know the land use that is there, which is the more accurate one. We know the climate data at that area, and also we know the topography for small area. If you take the average, you take one value for one grid, it's more accuracy. So the model that was developed consider this for small area, it calculates for each small area grid, and then make average for the whole catchment. And that is from the starting, it was the challenge to manage this. But after we find, when you are in the calibration and validation, you find the results, it predicts the reality. The results are more accurate. But the logic behind it was to apply the equation of the water balance for small area, and then make average for the whole catchment. And that's actually what makes this model to be more accurate. Thank you.
Any more questions? Yes, please. The person to distribute the microphone should be here, so that you are able to see everyone.
Good morning, participants and ladies and gentlemen. And thank you very much, Dr. Kundo, for your insightful presentation. I have two questions. One, government of Rwanda has been suffering from groundwater management. So my question is, could you please explain how this model can help in this ground management that Rwanda is facing in the way which is sustainable? That's one. Two, in your methodology concerning your model, you said you calculated the R naught. So what does it mean in the groundwater management when you calculate R naught? Thank you very much.
For the last question, I didn't hear well. It's
you said that R naught was calculated. So sorry?
Sorry, I use we use the programming called the ARA.
Oh, ARA.
It's a programming language that we use. Yes, yes.
Okay, maybe I didn't understand well. Yeah.
So thank you for the first question about the groundwater management. Recently, I was in the Rwanda Water Resources Board. There is a project there about the groundwater management in Akagera catchment. So it's a starting point in Rwanda. So we are now, the project is in the whole Nile basin, but in Rwanda it has a component of the Akagera. So we are working together with this expert, and we hope, I suggest the model, and even if there are still challenges, because the model requires more data, more specified data, and I hope if we can fund the all data together with Rwanda Water Resources Board, the government of Rwanda can, through the Rwanda Water Resources Board, we can achieve many in the groundwater management. But the project is there. It's in the Nile basin, and in Rwanda we have a Kagera project, And I can tell you that we are working together with this institution of the government so that we can see what can be done in the management of the groundwater as the main source of the water supply and the water that we use for irrigation in Rwanda. Thank you.
Okay, thank you very much, Dr. Kun. Any other questions, comments, or contributions from the participants? Students who are here, I want you to ask questions. I want to be sure that you are learning something. Okay. Next, I want a question from students who are here. Okay.
Okay. Thank you very much for Dr. Kun for your presentation. I really appreciated how your work have been constructed, but I didn't see in your work, you didn't present your innovation, your work. What was your innovation? That was the first interesting one question. The second one, you said that the case that was in Turkey, then I don't know if you can you recommend your work in this in our country here? Your result. Can you recommend your result in our country here? Or no? Okay. Another question is, I want to know how did you estimated your parameters regarding to the model developed? I just know how did you estimated your parameters? Thank you very much.
Thank you so much, Dr. Emmanuel. I will start from the innovation. As I mentioned, this topic has the main one innovation is the model that was developed. So this model we developed at the catchment level. It was one of the innovation because as I mentioned, I respond to question, the first question. The model itself, it can estimate the water balance quantity for the small area, then make average for the whole. So that was the first innovation. And the second innovation of this, there is another paper, but it is continuous to this one. It was in the recommendation, I recommended how we can couple the groundwater balance model and the groundwater flow model. It is how can we connect them and work together as one model. So it was the second paper, but come from the recommendation of this. Also, the paper is there, where we want now, in order to run the groundwater model, flow model, like model flow, we need the data coming from the groundwater, water balance model, like the upper layer of the groundwater recharge. So we combine the two models by using the Python codes, and then we create one model. That also was one of the innovations. So we have two innovations. And about the second, this work, I cannot recommend the result here, but I can recommend the methodology. So the methodology that we use, because the data are different, but the methodology used here in Turkey, it can be well recommended here in Rwanda. So that's rather than recommending the result, I would recommend the methodology because we found that it can provide the real result. And for the last one, I didn't present how we estimate the different parameters we use in the model, but I can say most of the parameter, the input, the data that we had, it was only the precipitation and the temperature, because they can be recorded from the meteor stations. But the other parameters were estimated. So in most of the estimation, because we were working on the big area, the spatial data, we used the GIS tool. The GIS tool supported to estimate many parameters that was used, and some part also in hydrology, but for the small area, like estimating like feed capacity of the area, the moisture content. Also, we did also, not in GIS, but also it's a part of the hydrology for the soil root zone parameters. So I can say many parameters were estimated using the GIS because it was for big area, but also the other parameters was estimated. But if I can give you the whole paper, I didn't present, but you will see step by step how the data were processed to have the input of the model. Thank you. We cannot hear you.
Thank you so much for your presentation. It was good and it is sustainable, yeah, for sure. Just have a simple question. You have found the dominant influencing factors of groundwater recharge, but I was wondering, what do you propose, like when you found that there is the factors of vegetation and the soil data? So I want to ask that, like, when, for example, the vegetation is the problem for the recharge of the groundwater, because you said that in the Turkey they practice irrigation, and I want to know what should propose when there is the factors that is being obstacles for the groundwater charges. What can you propose?
Yeah, thank you so much. I'm glad that one of my students asked a good question. And the question is about the data that we use for controlling factors of groundwater recharge. Actually, maybe I will start from the purpose of this work. The purpose was to know how can we manage the groundwater. And first input to the groundwater is the recharge, how the groundwater is increasing or decreasing. And when we use the groundwater in irrigation, in other activities, like in the area, we have many industries, we have many human activities that use the groundwater. So they extract the water, but they don't know if it is increasing or reducing. But for sure it is reducing because there is a high exploitation of this groundwater. So now, the question is like, if we get this parameter, how can we use them to manage the catchment? For instance, the result of this work was to see in land use and also soil, land cover, the parameter that can support the recharge, the increase of the recharge. For instance, can you give an example? Like we saw the alluvial soil correlate positively with the groundwater recharge. In this zone, one of the recommendations, because this area is more industrialized, there are many industry, it was recommended for this area of the alluvial soil to not disturb this area. Why? Because it increased the amount of the water that can increase the groundwater reservoir. And also for the other parameters also. But we need to balance, because we saw like where there is a forest, the groundwater recharge is less. Why? Because the actual evapotranspiration is high. There is no more water that can percolate. So we cannot say we are going to remove the forest, no. But we can see where we can, like, there is urbanization, like where they plan to put different infrastructure, how they can manage with this parameter and control them so that the recharge will remain to be there as long as the groundwater also will be exploited from the, by different users. So by one parameter to one, there is now another step to manage how to use the land. So there is a land management now so that the groundwater recharge will remain, will continue to provide the water to the groundwater reservoir. So this is how I can respond to you, and thank you, and I appreciate your question as my student.
Okay, thank you very much, Dr. Kund, for your clarifications. Let us stop here for this presentation. So if you have got other questions, you can still interact with him during the coffee break and lunch break. So we are now going to welcome the next presentation by Professor Coker. Professor Coker, please come closer. Okay, I will first introduce you to the participants. In the meantime, you can have a seat. Yeah, Professor Coker, who is going to speak to us now, is a Nigerian citizen. He's coming from Nigeria, based at the Department of Civil Engineering of University of Ibadan, in a city called Ibadan, in Nigeria. He joined the University of Ibadan as a lecturer, two in November 1991, and he rose to become a professor in November 2010. So he is a full professor in the Department of Civil Engineering of University of Ibadan, and he has been a professor since November 2010. His research interests are in the areas of water resources and environmental health engineering, as well as remanufacture and biomedical engineering. He will present physically a research work entitled The Application of Remanufacturing in Sustainable Remanufacture. Thank you very much. Professor, you may start now.
Thank you very much, the chair of the conference. I will be making my presentation on the application of remanufacturing in sustainable manufacture. And you have an outline. Are you sure it is connected? Okay, it's connected. You have an outline of what we'll be working on. Let me say that this is a work that we have been working with University of Strathclyde in Glasgow, Scotland. About 3 years ago, we got a grant together with them, and we began serious work in the last 18, 20 months because of initial constraints of finances. My colleague is here, Dr. Chibueze Archie, who will be making further presentation on this area on Wednesday. So effectively, we have the PI at University of Strathclyde, Professor Winifred Ijoma, as the lead author of this paper, Dr. Kingsley Oturu, Dr. Archie of Civil Engineering, the first two are of Strathclyde. Then a colleague at the University College Hospital, also the College of Medicine, University of Ibadan, Dr. Lushola Idowu, and then I am also there. So you have the outline, the presentation outline. I will start by giving us an introduction. Then I'll go ahead to talk about the process of reuse as a sustainable development concept. I will also go into the benefits that society stands to gain from product recovery, because this is all about product recovery. Then I'll also summarize the key benefits of remanufacturing for producers in developed countries. And it's simply because they have gone far in this concept. We are trying to tap into what they have done.
Professor, if you can, they can't hear you well. If you can remove your mask and be closer to the microphone.
I was just following in. I wanted to be sure that that's the protocol.
Okay.
Right.
So can everyone hear now? Those sitting at the back? Can you hear well? If you can't hear, let us know. Then we can improve things, okay?
Thank you very much.
Okay.
This is actually more convenient.
Yeah.
Then I will talk about the application of remanufacture in the construction industry, which is of interest to us as civil engineers, people in the built environment industry. Then there are design issues to also talk about, and then I will conclude. Now, let me say that the issue of remanufacture has got a linkage with some of the sustainable development goals. For instance, the issue of Goal 1, Goal 2, Goal 7, Goal 12. Like you and I know, Goal 1 has to do with the issue of dealing with poverty, making sure that as much as possible poverty is reduced drastically. Then Goal 2, quite similar, dealing with the issue of hunger. You know, we want zero hunger if it's possible. And then the Goal 7 talks about ensuring access to affordable, reliable, sustainable, and modern energy. This is always a major issue when it comes to manufacture in its entirety. And then in particular, what we're talking about deals with responsible consumption and production patterns. So if you look at it very well, we are talking about something that is in tune with sustainability. 4 obvious ones. There are less obvious ones, but let me limit it to those 4 obvious ones. And, you know, you find out that there have been a lot of issues about where do we get the resource, especially with the increasing growth, a dimension that is unimaginable in population all over the world, especially in developing countries. Very massive. Even for those in developed countries, the issue of industrialization, massive industrialization, globalization, and so on. So you are talking about increase in pollution, increase in the waste generated, and then you have a lot of problems even in getting the raw materials. So, not to talk about the fact that when you handle with these wastes, where do you take them to? The landfills can no longer cope. And people have now turned a lot of so-called places, they call them landfill, but we know that they are just dump sites. So it's a serious problem all over the world. And as such, we're looking at the issue of using remanufacturing as a sustainable concept to deal with this problem. It's a global problem. And so when our colleagues in University of Strathclyde, Glasgow, contacted us, we just know that this is the way to go for us, even in Nigeria. I don't know what the scenario is in Rwanda, but I can tell you that nothing like this existed before now in Nigeria. Nothing. We contacted the Nigerian Institute of Engineers. We contacted the healthcare facility, because that's the case study we are working with right now. So we know that we are in for a research, a work that is capable of making a lot of transformation. So what is remanufacturing? Because that is important to define at the onset. It's a means of returning a used product to at least the original performance specification from the perspective of the customers. You want to return the product to the original specification and still give what is called warranty. That is always important to customers. They want to be sure that if I buy this material, am I sure that I will be able to take it back to you guys if there are problems, deficiencies, or issues arising from the usage. So that is very important. And so it's an important reuse strategy in waste management, material recovery, and environmentally conscious manufacturing, because it is environmentally beneficial and can be profitable. You will see that shortly. That is the key thing these days. You're talking about reuse, repair, reconditioning, and remanufacture. You talk about 4 R's. That is always the way to go. And it's simply because it's all about sustainability. What had been in vogue before now is just not sustainable. So we must be thinking about how do we sustain not just the environment, even the process of manufacture, or else we end up with problems in our hands, population exceeding resource. So it's a serious issue. So you can see the process of reuse as a sustainable development concept. We call it the 4 R's, like I mentioned earlier on: recycling, repair, reconditioning, and manufacturing. Now, all of them are important because they help to limit landfill. They help to limit what to take to the landfills, and they help to reduce the need for virgin materials. If you don't go the way of manufacturing, what you are saying is that you must get virgin materials, new raw materials, to be able to manufacture. So that's why you will be thinking remanufacturing. And you'll see shortly even the relative advantages that remanufacture still offer compared to recycling. Recycling is good, no doubt about it. I'm sure that is well known all over the world. In Rwanda here, I'm sure you do a lot of recycling. But you can take it to the next step. You can take it to remanufacture and see, get further benefits. So that's what we are talking about. In every sense, it's a win-win situation if you can go that route. So you can see the process, the concept here, and how significant remanufacturing could be. You could have a state of virgin material, whereas you can extract the materials and you do some pre-processing. You need a lot of manufacturer energy. You use the energy. You could go the way of remanufacture or way of reconditioning. Whichever way, you have energy emitted at the end of life cycle of the product. And eventually you end up with stuffs into landfill. All along you have emission of transport energy as you go from one phase to another. So you can see one of the things that we are talking about, a major resource is the resource of energy. And this, as much as possible, you and I know that it's not really affordable, it's not really available all over the world. In fact, in developing countries, at least a scenario that I know very well, my nation Nigeria, the problem, major problem that the manufacturers are talking about is energy, 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 energy. If you can deal with energy problems in Nigeria, a lot of manufacturing will be sustainable, will achieve so much, we'll be able to reduce drastically the cost of products. It's a major issue. So anything that can help you to deal with energy in our concept in Nigeria is major. And I believe this is true to a large extent in Rwanda and in most developing countries. So that's why we are learning from these, our colleagues, what they have done concerning remanufacturing. So basically we have the three of them: repair, reconditioning, and remanufacturing. It's also known as component reuse. You reuse the components of an existing product. Instead of dumping it, instead of throwing it away, you reuse the component, you find a way to break it down, and then you recover products, and then you think of secondary market process. Because that is important. What is the essence of doing anything that cannot be translated, that cannot put food on your table? So this is very important. And these are the various production processes that use components from used products. And like I mentioned earlier on, they are preferable to recycling. As good as recycling is, they are still preferable to it. You will see the differences shortly. Of course, when it's recycling, that's well known. You collect, you sort, you process, and then you produce new products. They're quite similar, but not exactly the same thing. So you can see this table gives the advantage that your product recovery, which encompasses remanufacture, has over recycling. Now, if it's the product recovery, it's an addition process. Addition in the sense that you add value to the waste products and you bring them back to working order. If it's recycling, it's a reduction process. You reduce the product to its raw materials, and then you now find a way to possibly convert it to something else. You know, there are products that can be made, for instance, from used nylon wrapping papers. There are products that can be converted to your slippers. But it's a whole dimension of new product in its entirety. When it comes to product recovery, again, you use less energy and less resource during original manufacturing. And this less is lost via recovery because you can actually recover a lot. If you're recycling, you are reducing the product to raw materials, and in the course of that, you lose the bulk of the initial energy input and resource. So you can see the difference and the relative advantage that your remanufacturing offers. Again, energy and resource expenditure to obtain your useful product from the waste product is less via this recovery approach. You don't expend too much of energy, which is always a major issue, even resource-wise, compared to recycling. That is always the case. And then the highest form of product recovery, remanufacture, is typically much more profitable. There have been publications with partners in Scotland that have proved this, and we are also working in Nigeria to see whether the same thing holds in our setting, because our setting is different. It's a developing nation, works are still ongoing in this area. And particularly if you are dealing with large, complex mechanical and electromechanical products, this is where the cost differential comes out very clearly. It comes out very clearly. If it's just something minor, something small, you may not appreciate it. It may not be appreciable. And whereas generally, sometimes, some people are unwilling to use recycled material because they are unsure of the quality. I have people in the house who are doing fantastic work. At least I know of Dr. Labiron, structural engineer. I know of Dr. Kintayo, who is also into transportation and highway engineering, and some other colleagues here, maybe in Rwanda, in Cameroon, you know, Dr. Taku and some other people. One thing that is always major when you say, okay, I want to recycle this particular product, or I want to make up for this, is they will always ask you, how about quality? How about strength? Are you sure that the strength will be able to carry this structural load? People always ask, because you are saying you are recycling to a new product that we don't know. This one we know. So long we can guarantee the specification, quality-wise, we know. So that we can have the warranty again. But this one you are bringing in, we don't know. Of course, that is not to say that it's impossible. We have seen fantastic research results that show that when you recycle, when you use other resource, other material to replace, you know, things, you achieve a lot of cost reduction, and you still have the same quality, still have the same result, or something similar, something that is usable. But that's where remanufacture has an advantage over recycling. So you can see some of the societal benefits of this. This align surely with Sustainable Development Goals 1 and 2 in particular. You know, issue of no poverty, zero hunger, because it's a major issue these days, especially in a developing environment like ours. One, it has led to creation of employment. That has been the scenario, even in the West. And if it happened in the West, I can assure you that our people stands to possibly gain more. If you look at the enormous number of people in the informal industries in developing world, many people that they get their bread and butter, their subsistence, not by white collar jobs, not by being university dons, but simply because they are into private entrepreneurship, which is really the way to go, because the jobs are no longer there in many places. Jobs are no longer there. So you are creating a living for local communities. The local community will have, you know, something to lay their hands upon, something they can sell. In Nigeria, I don't know what the scenario is in Rwanda, but in Nigeria, there is a thriving market for what we call tokumbo. That's just to give us an insight of what we could achieve by remanufacture, by product recovery. Really, really thriving markets. A lot of people obtain their daily subsistence, they live, they survive because they are dealing with tokumbo goods. Tokumbo of all sorts. Sometimes of what you and I think should not even be sold. Can you imagine people selling underwears, used underwear? It's not the best, terrible, you will say, but I'm just saying it's something that happens that I know. So, but we're not talking about underwears in this case. We are talking about bringing materials to original product specification. So you can imagine if people can sell stuff like underwears and still sell. Some people still go ahead to buy. Now you cannot imagine if you can get a material put in a scenario that is more or less original products in terms of specification. People would naturally go for it, more so that you're giving warranty. So this is important. Of course, poor people who otherwise would not be able to afford them can now afford them. That's one other striking advantage that you get from product recovery. And there's a whole gamut of training for low skill and unskillable. In the last 6 months in particular, when we began to work seriously on this project in Nigeria, we've succeeded in having to work with some technicians, some technologists, that they too have some workers. They have workers that they are working with, that they are training in this area. In fact, in one of the times when Dr. Archie and I went there, we saw not just low skill and unskillable, but we saw students from a technical university. They call it the first technical university. Those of us from Nigeria know the university I'm talking about. Their approach is fantastic. They are university students, undergraduate students, but they believe in not just sitting in classes. They go right there, sometimes learning from the people that some of us would think that what do they know? I tell you, they know a lot. We can learn a lot from there, and we were pleasantly surprised when we asked them, and they said they are undergraduates, year 2, year 3, and they're working with this man that we are working with. We saw them working together. So we are talking about another advantage of building capacity. So we are enhancing capacity building in this area. That's training the next generation. So it's a win-win situation if you look at what we stand to gain, especially those of us in the developing world. There are also other issues to consider. You have establishment of new business models that can include effective reverse logistics systems. And so this will certainly ensure adequate quantities of used products to support the product recovery process. This is clear because you now use less of raw materials compared to what the scenario would be. But raw materials are not always easy to come by. The manufacturers will tell you, one of the problems we have in Nigeria today is having access to dollars. It's serious. Some airlines are having problems even repatriating their funds back to their nations because of scarcity of forex. The government is battling with this problem. And so sometimes, the Manufacturer Association of Nigeria, MAN, is crying out daily that we are unable to access raw materials for to do our work. Simply because some of the raw materials needs to be purchased using forex. So anything that can make you to reduce your need for primary raw material, which is the scenario in remanufacturing, product recovery, is just good for you. It's just good for you. You know? And it's simply because when you are using virgin raw materials or the virgin components, it will raise production costs and hence product price. If you know the level of inflation in my country today, you will marvel that, how are you guys coping? And it's simply because the cost of getting dollar is huge. Not just in terms of the amount. $1 currently exchanges for, before we left home, for about 65 local naira. Of course, you may say that's still better than Rwanda because I was told yours is about 1 to 1,000. But if you look at the scenario in Nigeria, you agree with me that it's not better. Because you may have some other things that you are doing to keep things low. You have a lot of things you are manufacturing locally.
It's unfortunate Nigerian economy is import dependent, a lot of dependence on imported materials. So an economy like that will really, really gain more from remanufacturing, because there will be a lot of opportunity to keep costs down, to use existing products instead of going for new raw materials. So that is really major. Again, it's obvious that consumers, they will want to purchase recovered products if they are significantly less expensive than new alternatives. Even the richest people in the world, nobody wants to buy things that are expensive when you can get the same thing for lower costs. So that is really, really important. So now, like I did say, I will talk about the key benefits of remanufacturing for producers in developed countries. I'll say that because they have established this. I mean, 2019, I was in a conference with them in Netherlands, Amsterdam, and from different parts of Europe. I saw presentations even from Asia, from North America, of what they have done with remanufacturing for producers in developed countries. All I could do in that forum was to make a presentation on recycling, because remanufacturing is totally new in Nigeria, still new in Nigeria. So, because you may be wondering, why am I not talking about remanufacturing for producers in developing countries? I can't talk about it, but I might be able to talk about it, say next year. The grant ends next year, and we are hopeful that by next year, we will have achieved stuff, we'll have results to show, we'll be able to compare and contrast what the benefits will be for our setting. For developed countries, it has helped them, it has helped the producers to address environmental and competitive pressures by delivering benefits such as the fact that they can compete more effectively with competitors in developing countries. Why? Because they are able to achieve the same targets but with lower cost. You and I know very well that even United States, many of the stuff that they sell in US are produced in China. Am I talking? Produced in China. And one of the reasons, for instance, the issue of labor. Labor is expensive in many developed nations. Though some of us have questioned, why are they putting China under developing nation? A nation that could put the whole world in wahala, in trouble. They are so powerful. And yet you are calling them developing nation. You know? I think the fear of China is the beginning of wisdom, even for United States now. You know what has happened between them. So, but why is it that a lot of products are produced in China and then exported to United Kingdom, for instance, United States? One of the reasons is cost of labor. So in a similar way, anything that can help you as a developed nation to maintain the quality in terms of product specification and yet lower your cost of production, still maintaining your quality is good for you. You can then be in a position to compete effectively with other people in developing countries. What those countries, for instance, have done is to put some, some parameters in place with their, maybe we call it NAFDAC in Nigeria. I don't know what to call it. Maybe you call it maybe Food and Drug Association, for instance, and some other bodies like that, that We also have what is called Standard Organization of Nigeria. I'm sure you have similar ones here in Rwanda, just to make sure that what is coming in from China, for instance, is of top quality. That's what they have done in the United States, United Kingdom, but a lot of stuffs are produced in those countries, and it's all about driving costs down, because they know if these things are done in the United States, it's going to be expensive. People will not be able to afford it. And of course, the producers will run out of market. And then you also have what they call brand name control. So you still take the stuff to the market, you still sell them, and you still maintain the brand, because, you know, don't forget our definition of remanufacturing. Yet, it's simply because you are as much as possible ensuring quality as in the original specification. And of course, since they can take back their used product from their customers, then a company, for instance, can control the access to a product at the end of the service life. That's another advantage that they actually gain from this. And one thing that is very, very major to them, which sometimes we don't care in developing countries, the issue of coping with penalties from environmental legislations. You must have heard of polluter pay principle. You pollute, you pay. And it's major. And it's not just, the payment is not just sometimes limited to financial penalties. There could be grave penalties that you don't want to even imagine. So for them, it's a serious issue if they can use a process of remanufacturing to reclaim the components, to use the reclaimed components, and still have a way, a profitable avenue for disposing their used product and components. So in every dimension, it's a win-win situation for them. They are able to avoid penalties that they may incur. They may incur the wrath of the government. This is not a society where man knows man. No. When you are penalized, you are in trouble. It's a serious issue. It also, remanufacturing extend the life of the product and so delay their final disposal. Anything that can delay the final disposal is good for you. It's good for you. Because disposal could be expensive. Expensive not only in the cost of what to do, but also in the cost of even landfills where you're going to take them to. And of course, there's increase in profit when you compare this to conventional manufacturing. And then there's the aspect of you also enhance your green credential. That is becoming an important portfolio now. You know, it's always a major issue, major environmental issue, even when you want to raise money in the capital markets. How green is the process? How sustainable is it? Is a major issue. I've mentioned the issue of increased profit, and then there is also the dimension of you enhance your product design, because remanufacturing will give you ideal opportunity to collect the failure mode information so that you can improve your design and development. It helps you, it enhances that. Now, this is of interest to us as people working in the built environment, construction industry, civil engineers, architects, planners, surveyors, and What of you? And this being a civil engineering conference, this is very, very important. So you look at how do we apply this concept to the construction industry. Basically, the environmental impacts of building occurs from this. Energy consumption, I've talked about that. Massive energy consumption is involved when it comes to construction industry. A lot of material use. You know what we are talking about. Use a lot of material. Is a major one. You generate a lot of waste from those materials, and through so many means, you use a lot of natural resources. Lot. In the course of that, you release hazardous substance, sometimes very lethal, toxic to the environment, to people, bringing in other issues of climate change. Of course, the solvents, even the packaging, and of course, the issue of air pollution also comes in. So, this is why remanufacture is very, very pertinent, very germane to us in the construction industry. And you can see all this must be considered throughout the total life cycle. Your raw material, acquisition, the pre-processing, the construction itself, the use, the maintenance, and the end of life of your built products. So this is really, really of interest to us, and I'm sure we can still talk more about this during question and comments period, because I want to finish very quickly. So, of course, you know that a lot of buildings are erected, even demolished each year in the world. New buildings coming up, I can see some coming up right on this university campus. You know, the PI was telling us yesterday about the huge need for civil engineers in your country simply because a lot of construction going on, which makes sense. This number is likely to increase because there will be need for new houses, new buildings. Even the government is trying to increase housing stocks because of the huge population increase that's going on. So you have a lot of buildings, but you know, can we always, are we going to be able to always construct new buildings on new sites? Sometimes in some places you don't even have the sites again. Some of our colleagues who schooled in England or Europe here will agree with me. If you know what goes on in England, you will marvel. The roads are so tiny. It's a powerful nation, yet the space is just not there because of their history. So you have insufficient capacity to support infinite quantity of new buildings that you can't. It's just not possible again because you need some of this land for agriculture, you need some for landfill. So we must be thinking the way we design and construct buildings. We must put our thinking cap on and see how do we put in remanufacture to change the way we do things. And then, you know, buildings, sometimes a building has been in use and then somebody just say, this does not suit my need again. It gets it destroyed and abandon it, or because the regulations, the requirements have changed. So we must be thinking about that as well. How do we even deal with demolition waste? How do we deal with them? And that's what has happened with respect to the phone industry. The phone, some of the people, you know, coming up with the handset, they will maintain the internal elements, but they will change the facade. So it's wisdom. It's part of the principle that they use. And of course, I've mentioned the fact that there's increasing pressure on landfill space. So we must be thinking about what to also do in this area. Let me quickly try to finish with the issue of design issues, because this is important. Because your design will influence so many things right from the beginning. So you must get it right. As engineers, design is of importance to us because you want to design to make sure that you optimize. Okay. Yes, I'm almost finishing. Just 2 more slides. So you must design for optimization, both from perspective of remanufacture and even manufacture. And like I said, the lead author, the co-PI of our grants, University of Strathclyde, Professor Ijoma, had done a lot of work in this area, and she found out that a key issue in designing product for remanufacture is avoiding features that prevent the product, the real product, or the components thereof from being brought back to at least like new functionality. What are some of these features that can hinder the remanufacture of any product? One, if you use non-durable materials, when you are trying to remanufacture, it will break easily. It will deteriorate, and as such, you will not be able to use it. Or you are joining technologies that prevent separation of components, because remanufacture, you want to be able to separate some of the components and give it, essential touch as will be expected in remanufacture process. So if you are joining technologies that prevent that, or they're likely to lead to damage your components, then that will not fly. Or you have features that prevent or discourage upgrading, that require banned substances or processing methods that may make returning to a new functionality cost prohibitive. Again, that will not work. Because don't forget, one of the essence of this is to make sure that we come up with something that is affordable. So in concluding, we are saying that economic progress must be tied with environmental concerns. If you are making progress economically, what about the issue of the environment? It's a major issue. Number two, sustainable development will be impossible without a shift in the way we manufacture. There must be a shift. Because currently, you have a lot of environmental impact that are negative, that are adverse, arising from the way we do conventional manufacturing. So remanufacturing is a major strategy in sustainable manufacturing. And it is critical to sustainable development because it generates more than 60% of annual non-hazardous waste. Manufacturing generates so much. So anything that you can do to remanufacture substantially reduce this amount of waste is good for us. And secondly, environmental issues are being factored into production costs, because not just because they are being penalized, but simply because there's a principle that is adopted in the West, maybe not so much in developing countries. We call it polluter pay principle. You see people in Africa's industries take all their stuff, dump to the water body. You can't do that in developed world. You cannot. It's a serious problem if you try that. So basically, this presentation described the part that the product recovery processes play in sustainable manufacturing by assisting through end-of-life management of products. And again, it has described the significance of remanufacturing, and we've also outlined some of the practical design for remanufacturing issues. Thank you for your kind attention.
Thank you very much, Professor Koka, for your excellent presentation. as we all know, manufacturing is an important topic for discussion, and I hope that we will be able to contribute more ideas. Prof, you can have a seat.
I'm a teacher. I'm used to standing.
So, in most of developing countries, we import more than we export. Can we reverse that through manufacturing? Can we reverse that so that we can be able to export more than we import? Because that is the way to develop the African continent. That is one question that we should think about. Secondly, everywhere in the world, they complain about youth unemployment, few jobs. Can we address that problem through manufacturing? Manufacturing is one of the ways to solve that problem. Okay, so I hope that we have an opportunity to think about that and maybe come up with the ideas. So I will now give you an opportunity for questions and comments. Yes, Farak?
I quite enjoyed it because it's very important to me as a person. In the introduction, you mentioned something which I want a further explanation on the fact that remanufacturing has to do with responsible consumption. I want a further explanation. How will you be able to control the consumption of the people? So that is number one. Then the second one has to do with one of your conclusions, that economic progress must be tied with environmental concerns. Recently, and I'm sure many of us are aware that I actually read a report that Ghana is battling with the issue of second-hand clothes, that it is causing an environmental concern to them in Ghana. So I want to now see if it is possible for remanufacturing to take care of this issue of second-hand clothes that are being dumped, not only in Ghana, in Nigeria. Many of us, that's what we depend on, but many of these clothes are useless. So not only clothes, shoes, all sort of things are dumped. No testing, laptops, they are dumped in the country, in the continent. So how would remanufacturing be able to take care of some of these challenges associated with this problem? Thank you, sir.
Thank you very much, Dr. Akintayo. If you get the title, okay, if it's possible for us to come back to it. Is it possible for us to come back to the slides? I have it here, but maybe it's possible. IT. We say remanufacturing is a process of returning a used product. I'm starting with the second question. Process of returning a used product to at least original performance specification from the customer perspective. When it comes to the second-hand clothing, you don't have a product with original performance. You have a product being used, overused, and that's why they are being dumped in our own part of the world. You can't do that in developed world. You cannot even just take any new material to England, for instance, or United States from China, if it does not meet the minimum specification in terms of standards, new material, because they will check it. In fact, they are more stringent. From my own experience, they are more stringent in England than United States. Maybe because US is big and massive. So maybe if they are doing that, maybe they will suffer. So their standard is a bit lower than United Kingdom. United Kingdom is smaller, and somehow I found out from experience that when I buy things in England compared to the same thing in the United States, it's higher quality in the UK. But in Nigeria and some of these countries like Ghana that you mentioned about, that is not done at all. Even the new things that are brought in, you buy them, they don't last, and nobody cares. Warranty that they promise sometimes, the seller will say, did I make it? And this is a man that wrote warranty. Dr. Archie knows an experience that I suffered. I don't know whether this year or last year. Bought his stuff, and the person gave me guarantee. Guarantee for maybe 2 weeks, I can't remember now. 2 week guarantee, can you imagine 2 weeks guarantee? I took it to him later that week, he rejected it. He gave me 2 week guarantee. 2 weeks. Can't even get it after 4 days. So, in the case of Ghana, Nigeria, I don't know whether you have the same scenario here, some other developing nations, what they are bringing in is surely material that have been used and overused. So, it is not remanufactured good. If they are remanufactured, where they are bringing the stuff, they ought to have enhanced the quality, and as much as possible, to the extent that the quality is near, that's if it's not the same. Ideally, it should be the same, but it's near the original specification. So when they bring it, you won't even know that this is remanufactured. You won't know. You will think it's brand new. They will even give you warranty because they've done so much. So it's not going to be, in that case, it's not going to be scenario. So if you can, the manufacturer can be successfully used to address that problem. But you know, that's why we still need to work on the technology so that if we have people who are into that, say in Nigeria, in Ghana, for instance, so when those materials are, if they are brought to those countries, then they will work on it initially and enhance it to an extent that when they are sold, you will not even think that they are second-hand clothes or second-hand that or second-hand this, second-hand computers, second-hand laptop. They will be almost as new in terms of quality. So the first question you talk about is actually one of these targets of the Sustainable Development Goal, that of 12. It talks about responsible consumption and product patterns. Sustainable Goal number 12. Remanufacture is about that. You see, because if you look at consumption, the usual thing when you're talking about irresponsible consumption is for you to use stuff, and so the moment it's no longer functional, you dump it. You throw it into the waste bin. That's irresponsible. And that's why the developed world, they are working on this area, because that is really, really common in the developed world. Really, really common. When they use stuff, I have found out from my little visits to these countries that when things are no longer working, unlike you and I in the developing world, that we are thinking about repairing them, you know, because maybe you look at the implication of buying a new one, the cost of repair many times is more than the cost of a new one. Dr. Jelabi has lived in England for years now. Am I talking, sir? The cost of repair. So it doesn't make sense for them to take a damaged stuff sometimes for repair, because when you want to buy a new one, it's possibly cheaper. But they are not thinking of responsible consumption and production. How? They will take those stores from you, they're happy to take those stuff from you and give you a brand new one. Because that thing that they're taking from you help them to control the way it's disposed, number one. Help them to limit what goes into the landfills, because they're taking it from you. I mean, when you know that if I drop this thing and possibly add a little bit more money, I can get the brand new, including cars. So many things. Refrigerator, television, computer. Just bring it, bring it. They tell you to bring it. Add a little more. Very, very, very attractive. Just a little more instead of buying the brand new one. And then you get a brand new one. Sometimes remanufacture that you don't even know at all. Are you getting this, ma? So it leads to what is called responsible consumption and product patterns. So in the life cycle analysis, it's just good because you control what goes into the landfill. Thank you.
Moderator, there is another intervention from someone who joined online.
Oh, online.
Yes. Yes.
Hi.
Yes, welcome.
Contributed. He was saying something that is really, really real. Let me start from the second question because I remember that one better. I think I'll have an idea of the first one later. The issue of mindsets is an issue that we are still grappling with in the issue of remanufacture. And that's why the West is also trying to push the principle to us in the developing world. Because if you notice, one of the things I mentioned, I talk about gray transaction, G-R-A-Y. That the consumer may not even know that this is remanufactured. Because as long as you can achieve the quality, can achieve level of warranty that is acceptable, then you go ahead. Because people still have that mindset. It's normal that when you know that this is not brand new, but it's a matter of time. If you go on with advocacy, we go on with massive mobilization, normally people respond somehow to changes. But this is the way to go. This is the sustainable way to go. If we do not start to think remanufacture, it's a matter of time. This is 2021. Imagine the world in 2070. If population continues the way it is growing, 1.4 billion in China, over 1 billion in India, Nigeria over 200 million, and United States over 300 million, and some other countries, massive population increase all over the world. And materials, stay the same. In fact, the pressure is more every day. So it's a matter of mobilizing, advocating, change of mindset, and seeing a lot of reasons why remanufacture should embrace. There was a time people were not thinking of even reusing. But you and I now, we are comfortable with reused materials. You know that this was not the original material. This is a new material from the old material. And you go ahead and use it. Because you know that that's just the way to go. Some of the plastic containers that serve as receptacle for our water, they're coming from recycled products. But you are drinking the water now, you're not even thinking of it. Many of us, we even put it in our mouth. You don't even bother to put it in a cup. It's because over the years, people have come to know that it does no harm. It does no harm. So it's a matter of, it's a process. It's a process that will take some time. And that's why efforts are ongoing. A lot of information being released in this area. In fact, one of the aims of our grants that we have with University of Strathclyde is to establish a center of remanufacture in Nigeria. That's one of our aims. Massive. And we're working towards it. I mean, by the time you have a center of remanufacture, which for now, nothing like that. In Africa's biggest nation. I don't want to say giant of Africa. Because I've gone around, I've seen that we need to wake up. But in Africa's biggest nation, nothing like center of remanufacture. So we must put that in place in a matter of time from this research work. Because that's the way to go. Then I remember he talked about profitability. I hope some other people heard him. Profitability of remanufactured. Is that what he said, the first question? What did he say about raw material? That what? That for remanufacturing. Oh, maybe he didn't get me very well. Your main raw material is the existing product. The components. You may have to break them down, you may have to work on them, but the main raw material are actually your products that instead of you disposing them, sending them to landfills, doing whatever you want to do, you are now working on it to remanufacture. So I think that one is straightforward. Dr. Taku, I think you are the one being. Yes.
Prof, for the wonderful presentation. I have a couple of questions. The first one has to do with cost analysis. Of course, you've told us verbally that the cost implication of remanufacturing is better, but since this is scientific research, I was hoping to actually see a real cost analysis that actually shows that it's better. For now, and I'll take it for your words because you don't lie as a person, but that will also be a great part of the research. Also, statistics shows that Africa is the import capital of the world. In fact, I was able to scribble down a few. The Guardian of October 4, 2020 describes Nigeria as an import-dependent country, the dumping ground for all consumables. And even the statistics for Rwanda is not really much better. The International Trade Administration shows that as of 2019, Rwandan imports total 2.7 billion US dollars, which was a 10.6% increase over the previous year. And this statistics hold true for most African countries. We are at that point where we are struggling to manufacture. And we know that most of the products we use are imported. We are hardly manufacturing in Africa. We know that there are a lot of factors that are militating against us, even thinking of manufacturing in the first place. Government policies, technology, costs, and all of that are working against manufacture. Now, if we are battling to manufacture, and we are now talking about remanufacture, is that not a frog leap? Is it realistic to talk about remanufacturing when we are not even at the manufacturing point yet? And the last contribution / question is that, as it applies to the construction industry, I know that in Nigeria especially, a lot of research has been put into reuse of construction materials, a lot, from aggregates to whole buildings and all of that. In all this research, I'm aware that only one of such researches has been applied to industry. The Abuja-Kaduna Road Expressway, which is one of the major roads linking the northern part of the country to the federal capital. Julius Berger has used RAP, reclaimed asphalt pavement, in one of the sections of the road, and he has met all standards. And so much of the research has been done, it ends up on the shelf because the industry is not really prepared to take this leap that Julius Berger, for instance, have taken. In your remanufacturing project, how does this come in? How can this gap be bridged? Because we've already done a lot on it. It's the application that is the major problem. How do you think this can be bridged? Thank you.
Thank you very much. Let me start from the last question. It's really true that a lot of research work, for instance, has been done on reuse of construction materials to do things in Nigeria, for instance, and a little of that is being applied. It's all about political will. If the government, for instance, who we know is a major stakeholder in providing infrastructure, put their feet on the ground. Come on. We find out from research from universities, from research institutes, that we can substitute some of the materials that are being used for construction and bring down the costs. That go and look at that. When they put their feet on the ground on local content, nobody can stop them. Local content, usage of local engineers. Oh, you can't get this project unless you show us that the bulk of your engineers will be employed by will be Nigerians. If they put their feet on the ground, but you and I know that sometimes that's not the case in Nigeria. I'm sorry to say this. Sometimes the preference is for foreign contractors who will even bring in technicians from Ghana, craftsmen from Ghana, neighboring country, when there are competent Nigerians that can even do that. What is the big deal about bricklayers? Don't we have fantastic bricklayers in Nigeria? Fantastic carpenters, people who are doing who are sand. Can't we use them? But we would prefer to bring it, and the government will allow it. So political will is important if you are to do that. It is doable. It's a lot rests on the government because they are the major provider of infrastructure. They are a major and key player in the construction industry. Number 2, or it should be number 3 now. You talked about the import-dependent nature of many African countries. I mentioned that in what I presented. But I think the way to go is, even when we import those stuff, let's start from that. If they are already imported, if it's possible for us to develop our remanufacturing skill as adequate as possible, and make sure that those imported materials do not get off to the landfill as soon as possible. In other words, when they are damaged, or when we say, oh, they are no longer in use, we're not happy with them again, we don't throw them away. We develop the skill locally. The capacity is built in such a way that people can rework them through the process of product recovery, remanufacturing. It will make a lot of difference, because you know you are not quickly going back to buy another one. Number two, you are not going to quickly dispose such in the landfill. So generally, it will be a win-win situation because you will do less of importation. If it's possible for me to set the imported material in a better perspective, then I would have succeeded in improving things and saving money. But of course, you and I know that the way to go ultimately is to even manufacture locally. Manufacture locally instead of depending on importing toothpick from Netherlands. It's silly. It's strange. So manufacture it locally yourself, and you won't need to spend your hard-earned foreign exchange in importing those stuff. I remember that the number 2 question you asked is the issue of I don't know whether it's the issue of cost-benefit analysis, which obviously I mentioned it earlier on that we're not there yet. For us in our research group, we are still working on stuff. There are things we are working on right now. Our case study is actually healthcare equipment. We're working on healthcare equipment. We're looking, and that's a major issue because a lot of this healthcare equipment, they are imported, some are donated, and over time, within a short period of time, they are no longer useful, and they are dumps. We have what is called equipment graveyards in many hospitals. Graveyards, not of human beings, but of equipment. You get there like this, you shake your heads. It's horrible. Because after 6 months, after 1 year, equipment are dumped. Whereas we can work on those equipment even when they are damaged and do something to make sure that we bring it back to near quality stage that can still be useful instead of dumping them. It's a matter of building the local technology, working with. I found out that our people are sound. I know of Nigeria, and I'm sure it's the case all over in Africa. People are brilliant. Look at what they do with in the automobile industry, for instance. When a new car comes to the market, even if the new car, it's a matter of time, Nigerian automobile technicians, they will take their time. Before you say jack, they are able to repair, they are able to work on it, even if it's a new technology. Most of them have not even some of them have not even been to Lagos. Not talk about going to Cotonou or going to Ghana or going to Germany. But with a matter of time, they are able to come up with technology. I don't know whether I've answered all. Dr. Taku, did I answer, or is there anyone that I've missed? Because you asked 4 questions. Thank you.
We will have an opportunity to keep interacting during the coffee break, during the lunch break, but we need to be on time. So we have taken more time than planned, so let us stop here now and proceed with the coffee break. So the meal is ready. We will have 30 minutes for what has been prepared for us. And I would like to request you to please be on time. Okay, so let us try to respect the time so that other activities will not be disturbed. So people who are attending online, so need to be you need to make sure that the activities that we have planned are run on time. Okay. So there are 2 sets of meals, this side and that side. People who are sitting at the back there, you will use that door, that exit. So you will go that side, and people who are sitting at the front, you will go this side. So in order for us to control the social distance, because we are working under the COVID-19 circumstances, you will get the meal, then come back to your seat. Okay, so because we want to ensure the social distance. So go get the meal, then come back to your seat, have your meal here. Then after that, the sessions will continue. Thank you very much. Enjoy your meal. In the morning, we started at 9 instead of starting at 8:30. So we lost 30 minutes in the morning. And again, Professor Coca took more time than provided. You see? So you were provided 45 minutes and you used almost 1 hour and 30 minutes. You see? So you have also taken longer. So, but for the next presentations, please, we will not be flexible as we were for Professor Coca. So the amount of time that is allocated to you is 45 minutes. Okay? So after 45 minutes, I stop you, whether you have finished or not. So you must be ready. So we recommend you to try to use maybe 30 minutes so that we can save 15 minutes for open discussion. So that means after 30 minutes, I will stop you. You must try to present within 30 minutes. Next presenters, please, take note of that. You have got 30 minutes for the presentation and 15 minutes for questions and answers. So after 30 minutes, I stop you. Okay, so we are going to be strict as far as time is concerned. So now, how are you going to manage the time that we have lost? Because we need to think about the afternoon sessions. The session is planned in the afternoon. So for the lunch, we are going to have like shorter time for the lunch. So according to the program, we have planned 90 minutes for the lunch break. So instead of using 90 minutes, we are going to use 45 minutes for the lunch. So when the time for the lunch comes, please be as quick as possible. So we will have 45 minutes for the lunch. Okay? In that way, we will be able to recuperate the time that you have lost in the morning. Do you understand? So, most of the time. So that the afternoon plan will not be disturbed. Do you hear me? So those are some of the remarks that we need to consider, so that our program can run well. IT team. Check. Not yet. So she should be on within 2 minutes. No, let us be patient maybe for 5 minutes more. If she's not on, then we. Okay. Anna, we are still seeing the first slide. Maybe you can. Sorry? Can you slide down? Can you show the next slides? we are still seeing the first slide. We are still seeing the title of your presentation. No, we can see the title, the decommissioning of pipelines, a review. That is what we can see.
Okay, so it's my turn to share my slide. Sorry.
Yes, I think we can. IT, can you expert? Can you help? IT team, check if you can help. Maybe if you can be able to show the screen from here. Okay, cool. Yes, we can see now. Okay, thank you.
So maybe I'll do this way instead of. Right, okay, so where I started off here.
where he can see people.
Thank you for a wonderful presentation. One of the challenges with pipelines in parts of the developing Africa is that some of our countries here have terrorist activities that impact on these pipelines. For instance, we have separatists or some terrorist groups blowing up pipelines. So in your pipeline manufacture as well as decommissioning, how can you bring this factor into your work? Thank you.
Well, I think
We are also looking at the environmental impact. Now, sometimes when these pipelines are blown up, oil spills also come into effect. And so it presents a bigger problem when we want to decommission pipelines in that kind of situation. That's what I was looking at, basically.
right, okay. Yeah, so that is the problem. The environmental impact is something we are carefully looking at. And as part of this project is looking at different assessment tools of how we can prevent this, and that will be one of the we are looking this comparative assessment, and depending on the technology that we will want to adopt, will be related heavily on this environmental impact. So if there is this bloom of of the pipeline, whether it could be the way you describe, or in terms of sometimes actually they're looking in decommissioning ways of removing that is through explosives, and that has been a big question. So they're not banned, and that could maybe relate to your question. They can use with it in a particular place, and then looked environmentally, that potentially could be a way of decommissioning them. In terms of getting the right environmental tool, that needs to go through comparative assessment, and then we have biological marine environmentalists that could potentially look into that and address that question.
Okay, thank you. A question from students? Yes, please.
Thank you. I have a question on the design of pipelines. There has been like a crisis of leakage of pipelines. So how do you ensure that in the design of that pipelines there will be no leakage, especially in the water bodies? Like for example, in the recent days, there's been a leakage on the California beach of the oil pipelines, and it is so harmful on the marine life. So how can you ensure that in the design of that pipelines there will be no leakage? Yeah. Thank you.
Yeah, it depends on how that has been caused. I guess if that is corrosion, or is it the bending and the cracking. So that is why we have design of different. We were talking about the internal and external corrosion. There's a big list of different things that these pipelines need to be there is another thing that is important is the maintenance of these pipelines and how often they are being checked, you know, the healthy monitoring program, and that is something that Shell is looking into.
Félicien Majoro, be ready for your presentation. Félicien Majoro is an academic staff in the Department of Civil, Environmental and Geomatics, Geomatics Engineering of University of Rwanda, College of Science and Technology. He's going to talk about soil erosion modeling for sustainable environmental management in Sebeya catchment in Rwanda. Félicien, please, come on.
Good morning, everyone. My name is Félicien Majoro. I am a lecturer at University of Rwanda. As a research for this event, I am on the last phase of PhD. I am in a PhD thesis writing. And because I have published 5 papers on this project, I selected one topic to share with you some results. Soil erosion modeling for sustainable environment management in severe catchment.
Is that which is right? Do you want to start with that one?
Okay. The second was the content, but content no problem.
It's okay. You can go back a little bit. Go back. Go to the previous slide. Okay. Okay. Cool.
Okay. The content of this presentation is organized like the content of a research paper. Then we can go to next slide. As an introduction, severe catchment, it is around here, the next district, Ruavu district, and some part of surrounding districts. And the problem which is there, soil erosion is the worldwide, it is worldwide an environmental problem. In Rwanda also, in many catchment, in all 9 catchments of Rwanda, the problem of erosion is present. The most cause of high erosion is the topography and the rainfall, which is excessive. For this project, for this paper, I am going to share with you the main objectives, which was to assess the causes and the effect of erosion in a severe catchment, and finally to propose some erosion control measures which can help farmers in severe catchment to manage the field. We can say some steps. First, we have investigated some causes by survey and GIS, using GIS to estimate the soil erosion, actual soil erosion of severe catchment, to propose from literatures various erosion control measures which can fit properly to the catchment. And for now, what I am going to present is the soil erosion model. We designed it, we developed it to help farmers to control soil erosion in the farms. The next. The methodology which was used, here I can say the location of severe catchment. It is in the western province of Rwanda. And it is the severe is one main river which runs from taking the source from Gishwati forest and having its outlet in Lake Kivu, about 48 kilometers. It has many tributaries. As a secondary data, there are literature review, agroclimatological data, and GIS data and applications. Primary data was the first site visit and some questionnaire to help to understand and to assess the perception of farmers. Because the objective of this paper is to develop a model, from literature there are many soil erosion models. And the simplest one, which is worldwide used by most of conservationist. It is USR, Universal Soil Loss Equation Model, or its modification, MASTR, or its revised RUSR one. And in this project, just we take one which was used specifically, which was the most used in this research. We have taken the simplest one, which is USR. USR is having 5 parameters, such as factor for soil, factor for rainfall, factor for slope length, and another chapter for cover, land cover, crop mixing, and some vegetation. And another one, if there is some erosion control measures, P. How the model, the name of the model, we have given a name to this. It is soil erosion source model, soil loss and crop yield model. How it has been constructed. We have taken, this is, we have taken a parcel map from Ministry of Environment. This is for any location in the country, there is a plot which is known as UPI, which has a code known as UPI, Universal Parcel Identification. This is a typical extract of severe catchment location. But globally in the country, this map of parcel exists. As counted in severe catchment, they are about 259,000 parcels. How the model have been constructed. This is the algorithm or model flow diagram. Normally, it is GIS is taking the whole catchment. It is evaluating global. While this model is proposed to evaluate soil erosion at each parcel, at the level of parcel. Then, after obtaining soil erosion from one parcel, we totalize to get soil loss from the whole catchment. Another estimation was to predict crop yield. For critical parcel, because all of them are not critical, because when the slope is greater than 60% degree, it is not recommended to provide agriculture. Then we totalize a number of arable parcel, and we predict soil loss and deduce crop yield. This is the model which has been developed. Then to estimate the soil loss, A, and after to go to estimate with a linear assumption correlation between soil and crop yield, and we have predicted for each critical parcel, we have predicted crop yield also. data analysis. No, next. Data analysis. They have presented the results. Most of the case, source model, it is a spreadsheet. It is Excel sheet which has many columns and which finally calculate soil loss and estimate crop yield. The interview has helped also, and the ArcGIS software has been used to delineate and to map or useful factors. Results. With farmers interview, we have evaluated 4.5% of farmers confirmed some practice of erosion control, and about 95 said no erosion control. And we proceeded with GIS. We have estimated soil loss is an average of 130 tons per hectare per year, which is extremely high. We want to estimate each useful factor at each parcel. This was the idea. For erosivity, there is a formula, a linear formula, to estimate soil erosivity. Because we have a map of rainfall, by overlapping of those two maps, we extracted the value of the rainfall erosivity at each parcel. The same for slope length factor. For slope length factor, there is also an equation. The same, but for key factor or soil erodibility factor, we have checked the literature review, and because we have a soil texture map of severe catchment, we have gone through literatures and we have found some associated factors, and we have inserted all this value in Excel sheet for the whole parcels. C factor also for the main crops which are grown in severe catchment, according to Minagri and the National Institute of Statistics. We have taken about 13 main crops and the C factor from literatures, and we filled Excel sheet. P factor also, we have proposed to use where mulching is possible for a small slope, combined with anti-erosive ditches and drainage channel, bench terrace from 16 to 60% slope, and over 60 afforestation. Contour band, it was proposed also for small slope, 0 to 60%. And each factor for erosion control, also we feel the source Excel sheet with this factor. And we go to combination. Table 3.4, proposed combination for erosion control measures in source model. Yes, I think it is there. Ministry of Environment has proposed to split into slope range. Slope range 026, 62, 16, 16 to 40, 40 to 60, and greater than 60%. And he proposed erosion control measures, main one. And what we did, we have added some improvement. The first column, we can say it is P0. There is no erosion control measures. It is we can say it is the actual status, but even actual status, there are some existing erosion control measures. But the first one, simulation one, P1, it is if we accept to on each parcel to implement one erosion control measure. And the P2, we can say if we check, for example, 0 to 60%, we can say contour tirage plus crop cover. Its P2 is contour tirage plus mulching, and P3 improvement again. Then we can add anti-erosive ditch. Each element which is each control measures which is added, it become multiplication. We go to table of P factor, then we multiply those addition, those added. Typically, crop rotation also it is proposed by National Institute of Statistics. A linear relationship from literature, many investigations, many researchers have proposed linear regression, others, other shape, exponential, and so on. We have picked one, which is linear regression, and you associated 2 points. The minimum point, soil erosion, when soil erosion is the minimum, it means crop yield should be maximum. And when erosion is very high, it means no crop yield almost. Then we take this value for each parcel, for each crop, and for each for association of control measures. Then we have a prediction for all critical parcel of severe catchment. This is the minimum and the maximum crop for 13 main crops in severe catchment. For this model, the printout, what is the importance of printout? Because agriculture, agronome or technician can be in his office with this model, and when a farmer comes, he will give him his UPI, and he will tell which crop is planned to be cultivated. What the technician can give is a device. He can predict soil loss which will be, and he can predict the crop yield which will be, depending to improvement from P1, P2, and P3. If we improve again, the soil loss will reduce, and the crop yield will increase. This is the use of this source model. This is for slope, randomly selected between 0.6% as a slope range. If we select steep slope between 40, 60, for example, if you take this UPI will show, because we have fixed maximum soil loss on 137, somewhere the crop can be negative. If the soil loss is greater than the maximum we take in this model, it means negative means no need to cultivate. Only we can improve with P2. With P2, there is no negative prediction. It means P2 can run and P3 can be again improve more than P2. We have checked the results. We have compared this result with GIS. If we take 30 randomly data, UPI, and slope range, and soil loss, we can check soil loss estimation using GIS, and soil loss estimation using source model, then the problem is to accept if they have the average is the same, is almost the same. Statistically, we have used the F-test distribution and the ANOVA, analysis of variance, one factor. Then we found that the actual calculated F is less than F from F critical from tables, then which inspire us to agree with the hypothesis. Then the two average, the two means are almost equal. As a conclusion, we have developed soil loss source model, soil loss and crop yield model, which can be used by farmers. And for cultivable parcel, we predicted crop yield. What can we recommend? We can recommend farmers in severe catchment can use this source model. Someone can say this model is for severe catchment. Why for other catchment? We can say this, it is limited right now to severe catchment, but how it is constructed, any other catchment having parcel map, having soil texture map, and the same data as we have used in this paper, can construct, can develop the same model in other catchment. This is the end. I give thanks to my supervisors. You are which has given admission, tuition waiver, access to labs, and so on. And the UR Sweden program, because of grant, I have won a grant of 9 Rwandan millions francs to collect data. And finally, some friends, some people around who helped me in addressing different works of this paper, and the other papers also they have helped. Thank you for your kind attention.
It's now time for open discussion, questions, comments, observations, and we will have 15 minutes for that. Yes, please. Agenda?
Thank you very much, Coordinator. Dr. Felicien, I thank you very much for your elaborate presentation. When I hear about soils, in fact, I'm always moved to learn one or two things because particularly I am doing more on geomechanics. So you're talking about soil erosion modeling for sustainable environmental management in the Sebaya catchment. Now, I want to beg you to please go to the slide of your model diagram so that what I'm trying to ask as question, we can follow from there. Just the slide where there is a flow chart of the model.
Flow chart?
Yes. Okay.
How can we go back? How to go back?
IT, please. The presentation screen.
IT?
In any case, let me just ask the question so that when the slide comes up, we can follow from there.
IT can help. People of IT can help to go back.
Okay. Okay, you made mention that when the gradient, during your presentation, you made mention that when the gradient of the soil slope is greater than 16%, it is not good for agriculture. I think that I quite agree because it's natural that in most cases, if we plant agricultural crops on slopey landscape, probably there may be some erosion that can remove the topsoil nutrients and all that. But particularly focusing on your topic, which is modeling of erosion, I was wondering about the parameters that you used in developing this model. I don't know if you took into consideration the permeability of the soil, because when you talk about the gradient of the soil and you quantify it to maybe a certain percentage that is not good for agriculture. And we also know that Darcy found out that the flow velocity of the soil is proportional to the gradient. Now, I wanted to find out which measures did you take in your modeling to address the issue of the soil permeability, because I didn't really follow the flow chart of the model very well because I couldn't really see all the parameters involved. So I just wanted to know what measures you took to consider the permeability of the soil during this modeling of internal erosion. Thank you.
Okay, thank you very much about this important question. Soil permeability. This is the chart. soil permeability, soil cover, there are together. There is the soil type, the soil cover. Okay. Suppose it is splash erosion. Splash erosion will try to dig from the soil. If there is a cover, land, if there is land cover, if there is vegetation, it will not be able. If there is no sufficient protection, the soil will be dug. There will be dug, removed. Is the definition of soil erosion is the detachment. If we protect, there is no detachment. This factor of permeability, it is expressed in this K factor. It is in K factor. Because soil texture will behave differently. This, if you say wet soil, dry soil, coefficient of permeability may change, but it is normally it is estimated in standards from this definition. What have we took? What we have taken? We have taken a useful model, as you know. Then we try to estimate or useful parameters. In such way, if you ask me, can you go to analyze other soil characteristic with or useful factor? I think it can be another study. If you ask me effect of permeability or moisture content, or there are many other parameters. It is not, it is complex, this model. It is not just like now, I can't say, you have to make investigation in laboratory, in testing, in simulation. Yes.
Yes, it's yes. I'm just keen. I'm just very keen to the assertion that you gave concerning the slope of a topography not suitable for agriculture in relation to your model. So the question I'm asking particularly is, how did you consider the effect of permeability as a parameter in your model, considering the fact that this model is built to being built to solve soil erosion problem for sustainable development. So the effect of permeability must have an impact on on maybe the slopy nature. Of course, as I mentioned before, Darcy, the French engineer, said the flow through soil is proportional to the gradient. So, and by that implication, you made mention that 16% slopy topography is not good for agriculture. So that is why I am asking, what considerations did you take, or maybe what effect does permeability have in the model that you have proposed? That's just...
Yes. More than 60% degrees. It is very steep. That's why between 60 and 16, it is proposed bench terraces. And because forestation also is to be considered also. We have to have a forest, and more than 60, it is reserved to forest. It is better. It is better instead of making trying to make treatment to be used as agriculture.
Thank you, sir, for that beautiful presentation. My question is similar to what has just been asked, sir, that is your model applicable to all soil types, clay types, silty, sand, loose types, dense type? Is it applicable to all soil types? Then, when I was coming from Kigali to this city 3 days ago, I discovered the terrain of the land is very steep. It's very steep, which shows that the erosion will be very tense. The effect of the erosion between Kigali to this city will be very, very tense. Can your model actually be used to curb the effect of erosion in such very steep terrain?
Okay, thank you, madam. Very good question. The first question, in the construction, when we were developing this model, this soil erosion model, which is developed for severe catchment, we have checked on the parcel map the soil texture. If we find for another catchment any soil texture which is not on the catchment, then you have to investigate how other researchers what have them proposed as a P factor, as a K factor, and so on. For severe catchment or soil texture which has been observed in a parcel, in our parcel, there is no other type of soil texture we can mention. For another, what did you say about steep slope? Yeah, the model can be used for any slope. Because if you agree, the same as the first the first participant who asked, if the model, if over 60%, if the model can be used, yes, it can be used. If you agree with me, then you can cultivate, you can implement a forestry over 60%. When it becomes more than 60%, in this model, it is agreed. Ministry of Environment has proposed, we have put reference, then it is proposed for afforestation.
Thank you very much, Felicier, for your nice presentation.
Can you come here a little bit, just 1 minute? The DVC in charge of academics and research, it's a good idea to know about him, to know him. Maybe stand here, you can ask your question from here so that people can also see you.
Right.
So he's the DVC in charge of academics and research here at Ines. His name is Dr. Karist Yadufashish. So he will also address you in the evening at the end.
All right, thank you very much, Chair, for the floor. Actually, I have like 3 questions that I want Felicia to help us to understand. One, you said you have addressed a questionnaire, even if I think it was to be a scheduled interview because you said you use an interview, it shouldn't be a questionnaire. So it was addressed to farmers. So I want to understand which kind of sampling type you've used. Is it purposive sampling? Is it simple random? That's one. 2, you said you performed the correlation between yield and type of soil. So, but we've never understood which type of test you've used for correlation. That's 2. 3rd, you said you used F-test and an over 1 factor. So, and you said 2 means were equal. Were you testing many differences? So if 2 means were equal, was this statistically significant? Thank you very much for your presence.
Thank you, DVC. The first question is to know it was about farmers to know. We have used the questionnaire and the sampling was random, was fixed randomly. For I think for other 2 questions.
The second question is, you said you tested correlation between yield and the type of soil erosion. So I was asking which type of test you've used for correlation.
We did not test. We have checked how other researchers are proposing. Okay. Some of them are proposing linear relationship. Others are proposing exponential relationship. Others are proposing relation between soil loss and the soil depth. And what did we take? What did we take? We have just picked the one of them, which was motivating, which was interesting for our research. It is simple. We have checked, we have agreed with linear relationship. No other test we have done. The test we have done is to check if the mean are the same, nothing else.
Okay.
So, comparing with GIS data. GIS results and Sorosi model results. We have checked if the mean are the same.
All right. Actually, for me, it was my third question. So if means were the same, so do we take it statistically significant? That was my last question. Thank you.
Okay.
Thank you for your interesting talk. And before we can end this session, here we have got a person from Rwanda Institution of Engineers. Papias, you said you are going to leave after this session. You go. Can I give you 2 minutes to say something, if you wish? Okay, please come here. So he's representing the Institution of Engineers of Rwanda. So he's representing the Director General. You can sit here. Have a seat there. Just 5 minutes, but don't exceed 5 minutes.
Good afternoon, everyone. I'm very happy and excited to be here. I have been here since morning, and I was excited by the talks that have been shared since morning. It's a good sign for the country, and it's an engagement that deserves its worth. Thank you very much. Like he said, my name is Kazawadi Papias. I am the past president of Institution of Engineers Rwanda, but currently I'm the president-elect of the Federation of Africa Engineering Organizations, which is an umbrella organization that brings together all engineering institutions in Africa. And it is headquartered in Abuja, Nigeria. I'm also the chairman of Anti-Corruption Committee for the World Federation of Engineering Organizations, which I started since 2019. So I'm actually wearing the 2 hats, but this is the first of its kind where the institution of academia institution is engaging the engineering profession. And the reason I say I'm very much excited is because when we meet in different fora that we go into, we find that the most successful countries in terms of their development comes from the tripartite engagement. What I want to mean in tripartite engagement is where the academia engages with the industry practitioners and the professional bodies. The Rwanda Institution of Engineers is a new institution which was established by the law since the law which was enacted in 2012, but it is trying to catch up with the other institutions which are more than 100 years. But the reason it is motivated to do that is because it believes that development of a country is the result of the tripartite arrangement and engagement, of which Ines Ruhengeri has already done it. I remember when I was still a president, we participated in validating and adding our inputs in terms of the civil engineering programs and surveying, of which we believe, I think, or even on the job market, in terms of the surveyors, I think you are good and you need to keep it up. So I don't have much to say. I would have loved to be with you up to the end, but because of the engagement of my work, I have to leave because I have tomorrow morning at 8, I have a meeting in Rusizi, and on Wednesday I will be in Karonji, then in another district. I will get back, I think, on 4th. So I wish you fruitful deliberations, but as a participant of this event, I would suggest that all the presentations probably shared to the people who attended, because the knowledge shared is not lost in vain. I thank you very much.
Thank you very much, Papias, for your remarks. So it's now time for lunch, but before we can go, I want to let you know that we will give certificates for everyone who is attending this conference. So on Wednesday in the evening, just go to the Central Secretariat, see the secretary for your certificate. Okay, whether you are representing something or not, we will give you a certificate. Even students, we will give you certificates. On Wednesday in the evening, go to the Central Secretariat to collect your certificate, okay? Thank you very much. So as we did for the coffee break, we will go and have our lunch there, then come back and have it where you are sitting now. And always watch the distance. So to make sure that we are safe, okay? Keep the distance as you go out and as you come back. So those of you who are sitting at the front, you will go this side, and the ones who are sitting at the back, go that side, okay? Enjoy your lunch. Thank you. Have your attention, please. So we have got 3 moderators for this conference. Okay, so I have moderated the morning sessions. In the afternoon, we are going to have Dr. Foraka Kentayo. She's an academic staff at University of Ibadan, Nigeria. She will be the one to moderate the remaining sessions of today. Then tomorrow, I will work with Dr. Emmanuel Rukundo, the HOD of Civil Engineering here at Ines. So I will now allow Dr. Kentayo to continue with the remaining session. Thank you very much.
Thank you, Dr. Franz, and good afternoon, ladies and gentlemen. You are welcome to the second session of this program. In the first session, we had 4 presenters. You know, it was hybrid, physical, and virtual. We are going to have the same thing in the second session. We are going to have 4 presenters. We have Professor Akisoya, Dr. Jelabi, Dr. John, and Dr. Taku. But Professor Alfred Akisoya, who is a UK partner in this project, is going to be the first one to present, and it's going to be a virtual one. The IT people, are you ready to admit in Professor Akisoya? Professor Akisoya is going to present for 25 minutes. Then we have questions for between 5 to 10 minutes, and then we end that aspect. IT? Okay, maybe before he comes in, like I said, Professor Kinsanya is from the University of Aberdeen, UK, and is our UK partner in this project. So he's a mechanical engineer, actually a chartered mechanical engineer. Let's just be a little patient to admit him. Okay. If you know the central theme of this conference, is repositioning civil engineering education for sustainable development. And education is about receiving and giving. So, and I'm happy we have our students here also to benefit. So it's not just we are preparing them to take over the economical development of Africa, like Dr. Francois said in the morning. We don't want only foreigners, the Chinese, the Japanese, the British, to come and develop Africa for us. We know what we need. So this conference is also in line with that aspiration of Africans, even to take control of our situation, to take control of our economy, to take control of our infrastructure. So I'm happy the students, if you were my students in Nigeria, we ask questions in our exams, but I'm sure it's not only just asking questions, but we want to motivate you to take over control of what is happening in Africa. IT people, are you ready? Okay. So Professor Akisoya is going to present a paper on an assessment of failure initiation in asphaltic bridge joints. An assessment of failure initiation in asphaltic bridge joints. So let's wait and see and benefit from what Professor Akisoya has to tell us. And interestingly, Professor Akisoya is a Nigerian. He actually had his first master's degree in the University of Ibadan. And as I've seen many of us, we have from the University of Ibadan, or from Nigeria, let's say University of Ibadan, Nigeria, because we also have Dr. Taku. So we don't want to, we are one in Africa. We are from Cameroon, we are from Rwanda. So Africa is one when it comes to moving Africa forward. We want to develop our own continent. So Professor Akinsanya will lead the presentation this afternoon. Thank you very much, Professor Akisoya. Please, let's appreciate him. Do we have questions? Questions is an interesting paper, and you know, it is the overall aim is to promote, is to extend the service life of our bridges. That is the overall goal. But of course, it is broken down into main objectives. So, do we have questions, Dr. John?
Okay, thank you very much. It was a very interesting presentation. My question, it comes to FEM models. So when defining interfaces, contact in FEM, so I want to know about the properties or some parameters. So do they come from experiment, or it's a value from other previous researchers? So I want some clarification on that. Thank you. Okay, so thank you. But the other thing is about delamination. So did you consider that in your FEM model, maybe to show with how the failure, so how the joint can be delaminated, debonding or delamination? Okay, thank you.
Thank you, Prof. Yes, one more. We take two more questions, one from researchers and another one from students, if they have any to. Yes, Dr. Taku.
Thank you for the wonderful presentation, Prof. In some African countries like Nigeria, normally we know that bridges and pavements are designed for dynamic or moving loads. However, and I also know that your models were also made bearing that in mind. However, in some situations, like in Nigeria, for instance, we have gridlocks on bridges that spans into hours. roads and bridges that spans into hours. Sometimes we also have trucks breaking down on these bridges, and they could be there for days, changing the loadings from dynamic to static loads. Have you thought of factoring this into this model, especially when you want to apply it in a country like ours? Thank you, Prof.
Thank you, Prof. Any question from, do we have any student who wishes to ask? None? Even if it is only to show interest in carrying out research works in that area. Okay, from researchers. Okay. That will be the last question we take for this paper.
Thank you for your wonderful presentation, Prof. You showed the stiffness graph there, and there was a reduction actually from the maximum towards the abscissa almost to 0, and then from 0 rising to the maximum. What happens exactly at the fixation point there where the two graphs are meeting?
more questions, I think they will contact you directly via Dr. Francois. Thank you very much, sir. Okay. Okay, thank you. Yes, the second paper for this afternoon session is going to be presented by Dr. Adedokun Ojelabi. May I call him to come out while I read his brief biography? Dr. Adedokun Ojelabi is the director of the Industrial Training Coordinating Center, University of Ibadan, Nigeria. He's a Nigerian citizen and he currently resides in Ibadan, Nigeria. He was the immediate past director of academic planning, and as I've said, he is currently the director of Industrial Training Coordinating Center. And this center is responsible for handling the university students' industrial work experience scheme. He also lectures part-time in statistics. His research interests are mainly in the modeling, quality of life data, data analysis and public health. Modeling quality of life and data analysis of public health. His publications are in the areas of statistical modeling, health-related quality of life, sickle cell and planning, among others. Of course, he's here physically to present a paper on bridging the gap between theory and practice in the training of civil engineering students in Nigeria, the University of Ibadan experience, and the way forward. Thank you, Dr. Ojelabi. Kindly present your paper for 25 minutes, not more than that.
Thank you, Dr. Folake Akintayo. Good afternoon, everybody. Let me say that I am a minority here because I'm not an engineer from what you have heard. But I believe what we are sharing is something that has to do with the training of engineers and the way the university relates with the industry to join together in training the civil engineer. Actually, this presentation, I'm going to do some rushing through so that if we have a question, we'll have enough time for question. Now, by way of introduction, I said civil engineering has evolved beyond the original perception as a profession where one works only in the construction site. It has developed to such a profession where we require software and soft skills on site and an on-site knowledge to fit into the industry. When you look at the publication of the American Society of Civil Engineers, it says that there are essential changes that has come up in the practice of civil engineering in the 21st century. And it listed about 24 detailed aspects. And you discover that if you are going to be an accomplished civil engineer, to accomplish those outcomes, there must be an interface or a training, not limited to the classroom, but that also involve the industry. So that means that acquiring practical training to bridge the gap between theory in the classroom and practical experience in the place of work has become imperative in training the 21st century civil engineer. Now, this paper is to discuss the practice and the experience of the University of Ibadan in providing industrial training for the undergraduate civil engineering students so as to achieve a comprehensive civil engineering undergraduate education that is made up of sound theoretical classroom teaching as well as robust workplace practice in the industry. Now, let me just take some important dates and events. University of Ibadan was founded in 1948 and is the first university in Nigeria. It was founded as University College of London and became...
Hello, sir. Just so, please, we are not, the slides are not changing. The IT people, please, is there? Okay, please use it here.
Okay, the University of Ibadan was founded in 1948 and became as a University College of London, and it became an independent university in 1962. Now, Nigeria got independence in 1960. Around this period, there were high demand for graduates, both in the public and private sector. And as at that time, because the nation was evolving, the demand was very high. So everyone that was coming out of the university, thank you, everyone coming out of the university, in fact, as at that time, it's like they were the organizations, the employers, they were already looking for you even before you finish your final examination. Then, in addition to the discovery of oil, also increase the demand for graduates with technical skills, especially in the industrial sector of the economy. But no sooner than these engineers were coming into the industry, they discovered a lacuna. It was discovered that the employed engineering graduates were deficient in practical skills. So to be able to address this deficiency, the University of Ibadan started its faculty, what you now call Faculty of Technology, as Institute of Applied Science and Technology in 1972. And as at this point, the Industrial Coordination Unit was created in that faculty or in that institute at that time to actually solve this problem of bridging the gap. So by 1973, the Industrial Training Fund was established by the federal government of Nigeria to establish the Student Industrial Work Experience Scheme, which in some other clime were referred to in different, with different nomenclatures. For example, in the UK, it is referred to as the Sandwich Program. In the USA, in Canada and Australia, it's referred to as the Cooperative Education. And then in the Philippines, it's referred to as Cooperative Plan of Education. In South Africa, it is called Work Integrated Learning. But in Nigeria, we call it the Student Industrial Work Experience Scheme. Now, this partnership, this industry-university partnership actually started as far back as the 19th century. Some said 1840 in the University of Glasgow. Some said it's 1880 in the Royal Technical College of Glasgow. But it started in the United States in 1906. And the idea is because there is the need for joint efforts of the university and the industry to help in training engineering students. In 1989, the National University Commission in Nigeria introduced SciWest, that is the Student Industrial Work Experience Scheme, in the curricula of many other courses beyond engineering, so as to show the importance of the need for students to have an experience from the industry in addition to whatever they have learned in the university. Now, the Industrial Coordinating Center, where I am currently, became a center in 1996. I said it started in 1972 as a unit in the Faculty of Technology, but now it becomes a university wide center that caters for other programs apart from engineering. Now, these statistics we are looking at now is very, very important because we are talking about the University of Ibadan. In Nigeria, we have about 170 universities. 79 of them are private university, 43 federal, and 48 state university. Now, the University of Ibadan is a federal university, and the University of Ibadan is a big brand. It's a great brand, and I need to talk a little bit about the University of Ibadan. Because if you look at the webometric ranking as we speak, the latest one, which was released on October 1st, 2021, shows that University of Ibadan is the best university in Nigeria, number 6 in Africa, and belongs to the first 500 university in the world. So that's a university to cooperate with. That's a university to set up a linkage with. That's a university to partner with. Now, when you talk about the academic staff of the University of Ibadan, we have, as we speak, 610 reader and professors. The people we call reader in our university are the people they call associate professors in other universities. And then we have over 400 senior lecturers, and other lecturers form about 35%, that's 541. Now, there are, as we speak, there are 10 faculties in the university that is involved in SciWest, and 37 departments are also involved. We have today over 3,500 students that are enrolled in our SciWest in the University of Ibadan. And we have over 560 employers who are engaging our IT students. Now, the objective of SciWest, in summary, is to provide an avenue for students in higher educational institutions to acquire industrial skills and experience in their course of study. And the goal is to prepare students for the industrial work situation that they are to meet after graduation. It is also to expose students to work methods and techniques in handling equipment and machinery that may not be available in their institutions. As they are going through the practical, through the training in the institution, there are some equipment they may not be able to access in their university, but when they go to the industry, they see some of this equipment, they are able to handle them, they are able to interact with this equipment. And the people in the industry who have this vast knowledge of industrial experience are also able to take them through what occurs in the industry in comparison to what they learn in the classroom. Now, in the University of Ibadan, I've categorized our experience to what I call the practice and process. The practice is our customary typical, your this is off, please. The practice is a customary typical way or procedure of operating SciWest at the University of Ibadan. And the process is what I call the chains of actions or steps that we take at the Industrial Training Coordinating Center in order to achieve the purpose of SciWest at the University of Ibadan. Now, in the BMAS, that is the Benchmark Minimum Accreditation Standard for Engineering Training in Nigeria, the philosophy, to achieve that philosophy, it is important that engineering students must be exposed to practical application of engineering and technology to be able to solve problems. They are also to have adequate training in human and organizational behavior and management, developing in the products entrepreneurial knowledge. In other words, that is developing entrepreneurial knowledge and sense of public responsibility and spirit of self-reliance in the students, and then nurturing partnership between the institution and industry for effective program delivery. Now, as you look at the table there, our university operates the internship in industry, whereby we place our students in reputable engineering industry to undergo practical training. In the University of Ibadan, our civil engineering students are exposed to, we have a 5 years program. And within those 5 years program, at the second year, which is the 200 level, the third year, which is the 300 level, and the fourth year, they are sent to the industry. We have 3 streams. We have the first stream that's at the 200 level. They go for what you call SWEP. That is the Student Work Experience Program. They spend 8 weeks. That's 2 months. Then at the 300 level, they go for 12 weeks, sideways. They go to the industry. That's 3 months. That's 12 weeks. And then, sorry, I think I'm jumping. So that is, they go for 12 weeks. And then at 400 level, they go for 24 weeks. And then the course unit attached to this level is, at 200 level, the course unit is two. At the 300 level is 3 units, and at the 400 level is 6 units. So you discover that in the 5 years, they are spending about 11 solid months to go for this practical training spread over 3 years. Now, this is the table here is showing us that in sending our students for training, we give real priority to the private sector. Now, you will see, sorry. I think you need to change this, your battery. Now, you will see here, I've looked at the last 5 sessions in the way our students are sent to the industry. You find that in some places, we talk about government parastatals. Yes, some of them go to few of them go to government parastatals because some of those parastatals are not purely ministry. So they go there and they're able to, like the Ministry of, like when you send them to the Secretariat, for example, they can send them to water resources and they send them to other parastatals. But the majority of them are sent to the private sector. And if you look at that table, you discover that at the 400 level, practically, they go to the private sector. Now, what are the steps that we take in sending this student to the industry? We start by inviting from the department the list of eligible students who will be participating in the program for the particular session. And then we have what we call the student registration at the beginning of that session. We also carry out what we call a pre-placement orientation program. That is where we inform the student what they are expected to do in the industry. They are going there to learn. And as they are going to learn, what are the do's and don'ts of the industry? What are the learning outcomes and the learning objectives we are expecting from them? So that they are not just going to the industry for the purpose of making money. They know that they are going there as part of their learning. It's whatever they are doing in the industry is contributing to their experience and is developing them as a full professional, so that by the time they finish their study and they are in the industry, they are able to actually distinguish themselves. And then the training jobs. Yeah, for the sourcing of the training jobs, we have the center is in the forefront to look for jobs for the students. But there are some students also who have some links. So we allow them, we give them customized introduction letters. We allow them to go to the industry. Some of them, they will go and apply. Some industry will do exam for them. And then by the time they come back with their letter of acceptance from those industry, we'll still conduct interview for them, because we have to look at those industry, whether it's relevant to their study, whether they are going to gain any experience, or they are just going to that place just because the place is offering them holiday job and is going to give them some amount of money. We want to be sure that they are not just going there for holiday job, they are going there to really learn as part of their study at the university. So we conduct what you call a placement interview for the jobs that we have sourced, so that the student, if for example, if he wants to stay in the capital city in Ibadan, he wants to stay in Ibadan, where we have the university, or wants to go to Abuja, or the parents are living in Lagos, wants to stay very close to where the parents are living, we look for a job that is closer to where they are living. I mean, the industry that is close to where they are living, and we post them there. Now, what are the documents required? We have listed the documents. We have our 8 documents there that we give to the students. The general instruction, which tells them the manual, everything, instructions about how to go about it, how to complete the books, I mean, how to operate in the place of work. Then we give them the placement letter, which they take to the place of work. That is an official letter that the industry recognizes, and the industry knows that these people are coming from the University of Ibadan. Then we have what you call the job reporting form. Now, that is an evidence of commitment of training, because that job reporting form will be filled and submitted back to the center within 2 weeks of the training. That job reporting form assists the supervisor in gaining easy access, as details of the immediate supervisor of the student were being filled in the form. Now, the other document is the training logbook, where they record their daily activities, the summary of their daily activities in the place of work. And then we have the employer's evaluation form. This form is to be filled by the employer after the completion of SciWest, and it forms part of what we use to grade the students at the end of their program. Now, we have other 2 forms. That is for those who are spending 6 months with, in relationship to the ITF.
Hello, sir. You have 5 more minutes.
I'll try.
Okay.
Yeah. Now, after going to the industry and all that, they come back to do what you call a seminar presentation at the end of their training. Now, the essence of this seminar presentation is for them to be able to detail the experience they have gained, the contribution they have made to the company, the challenges they face, and the recommendation they are making. Now, well, this is the way we grade. Logbook is graded as 10%. We have the industrial supervision, 15%, employer's evaluation, seminar presentation, and work evaluation. Now, we also have the penalties if the student defaults in any of these areas. With respect to the logbook, that is graded by the people we call industrial coordinators. Those are the people that are working at the center, and that is 10%. Now, the employer's evaluation is graded by the employer. That is the industry-based supervisor, and that forms 25% of the total mark that is obtainable. And then we have, this is the form that the employer will grade. IT, please. Yeah, this is the form that the employer will grade. And then we have next there is the seminar presentation. That will be graded by the lecturers. Sometimes we have 3, 4 lecturers coming from the department, and one industrial coordinator will join them. And then we take average of whatever grade that the assessors give to the student based on 30%. And then we have the industrial supervision. Now, this is also based because we have the industrial coordinators and lecturers going to visit the students where they are carrying out their industrial training, and they are given 15%. Whether the student is present by the time they go to visit, how many times they visited, how many times they were able to find the student at the place of work, and that visit is done randomly. You don't announce to the student you are coming. You just go at random. You want to find out whether they are there in their place of work or they are going to do other things. And then, what do we have here? We also have the work report evaluation. It is the lecturers, their lecturers, that does that grading along the logbook. So you have a total of 100%. Now, what are the positive outcomes? Exposing our civil engineering students has led to a wide range of positive outcomes. Some of them are able to gain design and construction experience. They're able to solve practical engineering problems. Some of them have physical on-site exposure, risk issues, project management, and so on. They're able to relate theory in class to specific practical work in the workplace. They're also able to develop some level of competence and entrepreneurial spirit. We discovered that there are some students that will come back and then they develop the idea that they don't even want to be employed by government. They are thinking of if they can just get affiliated with an industry where they will, be mentored and then they can start their own. Then they also learn soft skill, like they also learn some soft skill, leadership, teamwork, positive attitudes, administration, all that, and then ethical responsibility. These are skill sets that are not likely, they are not likely to grasp in a classroom setting. Now, what are the challenges? Well, number one is the global list. We have the one that is global. I've divided that into four. Let me just rush through. We have the one that is global, that has to do with the pandemic, which has led to the reduction in the intake of our students as a result of some places that were closed down, as a result of the reduction in the number of the people you can put in the same place. So it has reduced. Some people will say they don't have enough space. Where they were putting 10 students before, they can only put 3 students. So that's a global challenge. And we also have what I call the national challenge, which has to do with the economic situation. Some companies are folding up because of the economic situation, the cost of doing business in the country and all that. There are also security issues. There are also unstable academic calendar, which has to do with the face-off between unions and the government. And then we have what I call the employer-related challenges. Some employers are not committed to positively impacting the life of the trainers. They just see them as tools to be used to, they see them as maybe source of cheap labor. And then I have the student-related challenges. Some of them prefer money they are going to get rather than the professional competence they are going to gain. Some of them have negative attitudes to training. You get to some places of work, they have run away. Some of them are incivil in their behavior, they are rude and all that. And then some students also evaluate the industrial training as of less important than their class lectures.
Thank you, sir.
Now, what's the way forward?
Okay. 1 minute for the way forward.
Way forward, 1, forge strong bonds with the private sector and foster continuous engagement and social interactions to provide or secure more opportunities for the student. I said we must redefine partnership. When I talk about redefining partnership, I'm saying that it is not just that we want the employers to train our students. The employer must also have something to gain. There must be this win-win relationship whereby things are, they can come and use some of our facilities. We can go and use some of their facilities. There should be this kind of interaction that goes beyond just train our students for us, and that is all. They should be able to also come, we can also invite some of them to come and take some courses or to come and take some seminars to actually be able to encourage the student. Then we must also respect policies of the organizations where they are going to do their attachment.
Thank
Then
you,
I said
sir.
we must also relate as professionals. And finally, In conclusion, in training a 21st century civil engineer, higher education institution must go beyond the confines of the classroom. There must be project-oriented activities that must be incorporated in engineering educational programs to provide much needed real-life experiences. And one of several ways this has been achieved and can be sustained is through the university-industry partnership in the education of engineering students. This affords the trainees the opportunity to widen their horizon by supplementing their classroom academic work with exposure to real-world civil engineering practice. This experience, according to American Society for Engineering Education, this experience offers an enabling environment to integrate desirable experiential skill that students will need when they enter the workplace.
Thank you, sir.
I want to thank you very much for listening.
Thank you very much. It's an interesting paper, and I'm sure our students there will be interested in what is being done in other parts of Africa, especially in Nigeria. So we have questions. Do we have questions, or we are satisfied with everything that is presented? Okay, HOD, okay, Ms. Jacqueline. I will start with the HOD.
Thank you so much. Tina Irakoza. The second one. Okay.
Let the HOD speak first. Okay.
We have, like you have some examples here. I was happy that you have a long time for industry attachment. I saw 8 weeks in the second year, and 12 weeks in the third year, and 24 weeks, almost 6 months. It's a
so together
it's
11 months.
Yeah, 11 months. It's a really long internship, and I hope the student can learn a lot to get the technical skills and the practical skills. But now my question is about how do you monitor? Like, for instance, here in Rwanda, we have some companies, the private companies, they may have the site for construction, but that activity may maybe take like 3 months. And the student is going there, and maybe in the last month of the industrial attachment, there is nothing to do there. And he spent all month without doing anything. So how do you monitor this? And also we have some site engineers who may sign the logbook for students that they participate every day, but they are not coming. Or students who go to the site and just work for money, as you mentioned. And so I want you to share your experience on this and how the university can ensure the monitoring of this, and or it can ensure that the outcomes of the industrial attachment are achieved. Thank you.
Thank you so much. What we have is that we have a combined we have a combined monitoring team, if you want me to put it that way. The lecturers on one side, and then the industrial coordinators at the center. You go to visit those students where they are having their industrial training. And the essence, we go there, it's not just to look at the way or what the students are doing. We also want to look at whether they are actually achieving the purpose or the objectives. There are times that we have to move students away from the place where they are doing the industry when we discover that the industry is not meeting the objectives. Some of them will come back to say, we are not doing anything. And when we discover that maybe they are just sitting in the office and they are not getting the practical experience, we move them from that place and post them elsewhere. So there is this combined effort. The university, at least the standard is that you must visit the student 3 times before they finish, especially those who are on 6 months. So at least you must visit them 3 times. The lecturers will visit them, the industrial coordinators will visit them at different times and different periods to evaluate what they are doing. And like I said, they come back to make presentation, the seminar presentation. From the seminar presentation, you can also discover whether the place they went to, whether we'll be able to consider them next time. If the students come and we discover that they didn't gain much in that industry, we will not post students there the next time. Then not only that, those who go on site, for example, before I left, there are people in Ibadan, and they were to take them to Akure. There is this understanding. The industry will let us know. The student also will write. They will come to the office to let us know that they are taking them to site. And because we need to know where they are at any point in time. So that if you want to visit, you just go and visit them where they are. So as much as possible, we monitor them to ensure that they are actually achieving the objective of the program. Does that answer your question? Is there any other one I've not touched?
Here also we have something we call the industry secondment, where we send, I know it's under this project, we send the staff to the site to learn more practical and bring them to and update their materials for teaching. Do you have the same practice also?
For staff?
For staff.
Yeah, we are developing that. We are developing that. We have not done that specifically for staff, but we are developing that where staff also can go to the industry and spend 1 month, 2 months to have this practical experience. That's in the offing. Thank you.
Let me just respond to that. Through this project, we started that in the Department of Civil Engineering. 10 members of staff have gone to the industry to let me, well, I wouldn't say to interact with them so that when they come back to the department, they can impact on the training of the students. So through this project, we've started that. Thank you.
Yeah, any other one?
Thank you so much. I'm Dina, a student here in Ines, Ruhengeri. For linking about the theory together with the practice, that is very important key point that can be considered before going outside. But sometimes you can see the big projects like high loads, like railways, and even the stadiums can be given to the abroad people like Chinese, Indians, and even the Americans. For looking that, you can say that, is it because the lack of knowledge among the students? But sometimes I try to figure out the cause behind this. For instance, I have a looking about the student themselves, even the lecturers, together with the institutions and even the industry. I want to mean for the students, sometimes they don't want to put all effort for knowing what is going outside, for not having that curiosity for looking what is going on in industries. Sometimes our knowledge can be at low level, but we can't, sometimes there are some lecturers who came at school with teaching us many things without showing us where to apply all those knowledge, like giving us some formulas without telling that we can use this formula for applying this and this, and get those formula like memorizing something. Another thing in institutions, sometimes due to the lack of, for instance, the infrastructures, there are the lack of materials. When we reach outside, you can see that is the first time for seeing all those materials and become our barriers after reaching outside. I want to help me to link all those causes the students themselves, the lecturers, and even the industry. Can you help me to link all those key points? Thank you.
Well, if I understand you very well, you are trying to say that there are some projects that are given to people who are not nationals. Am I right? So, well, it happens everywhere in African countries. It's not that we don't really have the professionals, so to say, but there are some political undertones. There are also some requirements. For example, in Nigeria now we have what we call the public procurement. Now the essence of the public procurement is to ensure that majority of those jobs are actually given to the nationals. But there are some that maybe the nationals do not have the equipment, the required equipment to carry out the project. But in the case of our students, we also link up with those big industries, big organizations, big consultants, and our students do go there to actually work. Like we have big construction companies like Julius Berger and all that. Some of them take our students, and our students work there. Now, when you talk about the problems or challenges, well, we need to understand what operates we need to look at the peculiarities, because we cannot generalize. If a student is having a problem in the place of work, or we are finding it difficult to understand what is happening where the students are posted, then we need to study that organization. And like I said, there are set objectives, there are learning outcomes that the students must be able to experience. And that is why we provide that training for them, the orientation for them, what they are looking for when they go to the industry. If they themselves are willing to learn, they are thinking of developing.
Let's begin to run. You know, this is an interesting.
They are beginning. Thank you. Yeah. Just give me a minute. They are beginning to think about their own professional competence. Then they will come back to say, "Look, I am not benefiting from where you have sent me." So it requires the will on the side of the student to want to learn, to want to gain experience, to want to be exposed. Is another thing for a student to just want to be lazy, looking for money. I just want to get the degree or the certificate and go. So it depends on the student. What is he looking for? Is he thinking of becoming a competent and accomplished engineer, or he just want to get the certificate and get out of the place? Thank you.
Thank you. I won't be able to take more questions on this. If you have further questions, you can directly send mails to Dr. Ojelabi. Please, we won't be able to take more questions. No, please write it down. Write it down. You will respond to it. Okay, just write the question. You will respond to it. Maybe after the paper, we can have one-to-one discussion. Thank you very much. So we are going to the third paper, and it's going to be presented by, please pardon me for the pronunciation. I've actually discussed with him. He has tried to teach me how to pronounce it, but I'm going to skip it. I'm going to use the English version. Dr. John. And Dr. John, please come for your paper. Dr. John is of the Department of Civil Engineering, and of course, is from Rwanda. Department of Civil Engineering, not in Nigeria, Her Highness, here in Ines, and is going to present his paper on development of mobile prefabricated shelters for rapid isolation of people during natural disasters and pandemics. This is going to be an interesting paper. I want to see. I have, even without the presentation, I've had questions that I may want to ask Dr. John. Please, Dr. John, you have 25 minutes. Thank you.
Okay, thank you very much, and I appreciate your time. So basically, of course, as he said, but he couldn't pronounce my name. I'm Jean de Dieu, so that's French name. Family name is Dawanima, but it's very difficult. Okay. Actually, I want to talk about development of mobile prefabricated shelters for rapid isolation of people during natural disasters and the pandemic. So, please. Okay. Okay, so I will be talking about the research background. So actually to explain what was the motivation, where my research topic came from, and also the problem we have, and propose some solutions so that can be taken. And also, so I explain about the connections we develop, okay, and also how you can assemble some units, like let's say building units, like structural elements, beams, columns. So of course, in my topic, you have seen that I use mobile. So mobile, which can means that you can, let's say for example, if you have a building here in Musanze, so you can disassemble those elements and then go and then install in Kigali, so anywhere you want. So yeah, that's about the topic anyway. Okay, so why then, where the precast concrete or precast structures come from? So why I get that idea? Because now maybe you can think of cheaper or construction speed, fast delivery. So you have like to know why prefabricated structures are more preferable these days. So we are running out of time. So we may meet something which is very urgent, and we need to isolate people, or you need to provide some spaces for people in need in emergency. So that's why we propose, we think of using some prefabricated structures so to solve that problem. So as I explained, so basically we have a pandemic. So we've seen in COVID-19, and also we have a war, and we have natural disasters, earthquakes, okay? So what's happening during earthquake? So people actually, you should not stay inside of your building. You have to move out, okay? Or sometimes if you have a collapse of your buildings, you have to find new spaces. Okay, but it should be done in a very quick way. You know, concrete structures, we should wait for concrete curing. Just it take more than 28 days or 15 days, 20 days, you know, concrete to get its strength. But that we are going to propose new connections and structural elements. Okay, and yeah, so that was the situation of China. So the Chinese were very fast people to develop some isolation rooms, and they develop also some buildings in just a very short time. So you can see, but you know China is very big, okay? So the problem with our country, we cannot make those small rooms because we need a very big area. So probably the option we have, we can go up. Okay, so I was thinking whether we can, you know, because those ones, they are so small, and you have one chamber which can take maybe 1 people. So you need a very big area. So I was thinking, why not to go up? So that was my opinion. And so you see now, so we have refugees, okay? So the way, you know, they are there, so they are exposed to bad weather, and then the problem with finding good accommodations, so we need to think about them as well. But those people, they need very urgent, okay, spaces, buildings.
So now we develop some structural elements which can be done just using concrete materials. Just concrete, because concrete is very cheap. So concrete is cheap. So, but what we did, we connect structural elements, for example, columns and the beams using dry connections. So metal plate. So what you do, the idea was to make like Lego connections, something you can work on. You can connect bolt and you remove, you disassemble, okay, by unfastening bolts, and you can take those elements apart. So those elements, so they have, for example, if you see, we have one part at the top and the one at the bottom. So let's say that's the column on the first floor and the other column at above. So the connection is just bolting. So you just bolt, and they are very great to make a moment connections. So you can use those connections to fasten and then make your building. So you can see we have also, but so those connections, so to be able to be validated, we've done actually a lot of simulations to see whether actually those connections can replace the conventional casting practices. So, but we saw very good results. So that's why we're able to apply them. Okay, so those are stresses. Okay, let's go back again a little bit. Okay, those actually shows the stresses. So what stresses can be observed at the connection. So that's, we've done that because it was not able during experiment to see every type of failure, okay, of those connections. So and then after we did, because the idea was to provide building in a very short time. So now we think about erection. So how can we erect our unit? So let's say you bring a column and you erect and you fasten, so to make a frame. So that was the one of experiment we did, okay, it was done to check how long you can assemble just 2 units, 2 floors of just columns. So that's where we just measure time, okay, and then we fasten the bolting. So, and then we saw that one column can be assembled, 2 columns can be assembled within 8 minutes. Just 8 minutes, you can fasten 2 floors of 2 columns. And then if you can add also beams and then make frames what we need as a structure, okay? So that was a very good experiment. And you can see the beams can be lifted and then being connected to the columns in a very short time. But the connections are bolting. So that's why it's very easy to do that. And then, so, you know, in precast, so actually now, so you can bring a lot of components at the site, and then you can fasten them using some connections. Usually steel connections are better. So all of those elements, they are manufactured at the factory. So which means you can have a lot of columns and the beams which are ready. So if you request 10 columns and 20 beams, then you can bring to your site and then you can make a building. So which is very time saving. Okay, and so we were able to publish one very good paper in engineering structures. So this was, it was a very nice paper on that, okay? And it was just accepted in just like 1 week. Just editor say it's okay. And we had, during the experiment, because we had to attach to make full-scale experiment. We attached the strain gauges to check the stresses, okay? And also, okay, so we make like full-scale experiment, like columns, very big, like a 2.7 meter high, and then we carry those experiments to the site, to the laboratory for testing. You can see 3 experiments were loaded for just being tested. And what we saw, you know, that was actuator, you know, just pushing the connection until it fades. So that was a very, very big experiment. So we conducted actually, full scale. So to see just how those connections, whether they can work in a very high seismic zone or, you know, in somewhere we have like impact loads, like such as a blast, whatever, you know, okay. And so we saw some failure modes. So the connections, of course, there was some weakness. There was steel plates, okay. There was delamination, and then some bolt failed during experiment. So that's what we saw. Okay, and but the important things was whether you can disassemble, dismantle capabilities. So you see, after experiment, we just we took upper column, and we can dispose anywhere we want. So which means, if you buy those elements, you can make a building somewhere, and then you can unfasten, and then you can go there and then make another building using the same structural elements. So you can use them at any time, okay? So that's what we did. We did the numerical analysis for that to check more failure modes. So those was the interfaces, okay, between those plates. And then what we saw after experiment was very good, because we saw that all the connections, there were like 3 types of connections. So the design strength of those connections could actually be used for a 20-story building. So basically, the connection we develop can work up to 20 stories. So of course, if you want to go more higher, then you need more stronger connection. So as a conclusion, actually we're able to provide a structure which can be used, you know, which is mobile. You can take it and then install it somewhere. And then also we develop a connection which can be supplied, structure members which can be supplied at any time within a short period, and they can be assembled and then also disassembled. So that was actually what we were able to find during experiment. So thank you very much.
Thank you, Dr. John. Dr. John presented for about 15 minutes, and it was power-packed, or let me say research-packed. So questions for Dr. John. I have one in mind, but I want to give others the opportunity first. Okay, Mrs. Engineer Yodele from Nigeria. Okay. I have 2 on this side already, another 2 on this side. We have time.
So thank you very much, Dr. John. That was a very brilliant presentation. My questions are 2. The first one, when I saw a mobile fabricated structure, I was expecting, did you consider the weight? Is it not heavy? Then what is the ease of transportation? Then did you consider the weight that will be induced by the structures on the pavement, on the road, in the course of transportation? Thank you.
Okay, thank you very much. That's a very good question, but you know, if you are talking about, of course, we have to consider the weight, okay? So when you are designing, we need to know what size should be used for, let's say, a low-rise building. So in a case, you saw it's very big. That one is for 20 stories. But if it's for like a G+1, which is 2 floor or 2nd floor, 3rd floor, you know, it will be very small. It will be like 200 by 200. It's not that heavy. So it's very, and transport, you are carrying just one unit which is 3 meter long as per floor height. So which is, it's not a problem. Yes, and we consider that. But the size comes due to the demand. So which building are you going to make? If it's a 40-story house, then of course we have a big element. Of course we have a problem with the installing if they are too heavy. But you know, here, if you've seen around, most of our houses, buildings are like very low-rise building. And we can apply very low light. And also we can use lightweight concrete, which is not too heavy. So we have a lot of solution. Thank you.
Thank you. Dr. Archie, your question. Okay. Number 3. Number 4. Later, let's have those.
Someone sent a question virtually.
All right, thank you for a wonderful presentation.
Sorry, Dr. Archie. Hold on. After Dr. Archie, we will have the virtual question before we move to the other side. Thank you.
So when I saw the presentation, I got interested because of, I was trying to link it to what Professor Coker presented in terms of sustainable remanufacture and manufacture, because obviously you can always remove parts and assemble them later. But my concern is, I don't know how that interacts. The components like the slabs and beams, how does that fit in with the foundation, because you have different soil types and stuff. So how does that work with the foundation, considering heavy weights and heavy structures? Thank you.
Okay. Okay, that's a very good question. Of course, I was not showing the entire components like a building. So if we start with the foundation, so basically foundation can be done on site, and which will not require, too much time. So what you do with the foundation, you just make like a concrete footing, pad footing, and then you have to make some anchors, and then you just bring the top column with the bolt, and then you connect those anchors from the ground with the columns, and you fasten. Okay, so the foundation can be done that way, and it will be done in a very fast way as well. Yeah.
Thank you. Please, let's have the virtual question.
Thank you. Someone asked a question. He was asking about the cost of these prefabricated shelters.
Okay. For the cost, okay, this research was not about cost, but of course, you can calculate by yourself. Just if you take like volume, for example, if you are talking about small house, let's say G+2 or like 2 floor. So small columns, like you can take a volume of concrete and times just the cost of that volume. Cost of a volume of concrete, it can be found, it depends on, maybe here in Rwanda, or it depends on where you can buy like cement, whatever. But the cost, since we did not manufacture this like for selling, so I can't say exact the cost right now. But if you want, you get to know the volume of concrete and times just the price, the unit price. And for steel structures, you can buy some, you can check, the price at the market. Usually for a small house, you will need just 4 reinforcement in just 1 small column, which are, I think, very, very cheap. And to cast at the site, in a factory, so you need to make like a pour foam, and you can make it just mixing, and then you can, I think that's where you can really get the exact cost. But right now, I don't know how much can it cost, but not that much. Yeah.
Thank you. Yes, on this side, there is somebody that's, okay.
Okay, thank you so much for the good presentation. Doctor, I would love to ask, I have 2 questions. One, I'd love to know the characteristic strength of the concrete used when you use a precast. The precast means the one that was fabricated away the site. Then you bring on the site. So I'd love to know, how do you know the characteristic strength of that concrete used? The second one, like for the small building, I saw that on the picture that you showed us, there was a steel around the column, the one that the bolt will fit. So I wonder, can that column, like a volume of that column and the steel, that plate where the bolt will fit, can that column cost the same as the one we cast? Or it will be not affordable for all the people, like the people who need to construct their small building? Thank you.
Okay, thank you very much for your questions. The first question was about characteristic strength of the concrete. Basically, when we design, so you know we have some different strength. So, but for this case, you can use either M25, 25 megapascal, or 20, but it's more better to use lightweight concrete. So lightweight concrete in design, I use just 21 megapascal, okay? But the choice of the strength, it comes with the demand of how big is your building. So because you can even use 25, it's okay. So there is just, as you know, to get the strength, you need the mixing ratio, okay? So what cement, sand, and the water, you know, and sand. So how much you are mixing. Depends on the mixing design, then you are going to get the strength you want, okay? So which means any strength can be manufactured, but you should use lightweight concrete, okay, which is actually lower strength compared to the other one. And the second question is about cost. I think you are, we know steel structures, they are more expensive, and then now my connections has plates, okay, which are steel, you need bolting and you need steel, which is expensive. So to me, now you need to compare, there is about cost, okay, and also time. So now we are actually someone can bring a lot of money and ask you to make a building in 2 days or 1 week. But he has a lot of money. Then we can supply him. But if you want to wait, like for concrete curing, and you have a lot of cleaning at the site, like a normal conventional way, you should wait a month so to get into the building. So in that case, my column, my structure elements can be, as you can see, can be higher as a cost, but if you see the speed of construction, or so how, I mean, if it's really needed, very emergency needed, then my connections will work. So about the cost, my connections will be, my columns will be a little bit expensive compared to the conventional one. So it's up to what you need as a client. Okay, thank you.
Thank you. The last question.
Thank you. Thank you for a good presentation. My question is this: according to the physical form of Rwanda, sometimes we call it Rwanda of 1,000 years. I would like to know if your project, if your research can save some areas lost by preventing something we call a manegeka. If you can work in the area, dangerous area.
Okay, so
I would like to know if your research can save the areas lost in preventing of a manegeka.
Oh, okay. So actually, he's saying a manegeka means actually it's a small, you know, like slums, you know, like
Dangerous habitation.
Yeah, it's actually like, you talk about slums, right? Yeah, like slums. Very like, we have like a very bad, living standards, housing, so yes, of course. This one, because as the last slide, I showed you that this can work for very high-rise building, like a 20-story, 30-story. So of course, you will create a space because we don't have, Rwanda is very small, okay? So we cannot have that, we don't have that big area. So the option we have is actually to go up or to go down. So the situation when I was in Korea, I saw basement, like 8, 10 basement, but just no people were living there. Only they were just parking, okay? But if you go to Kigali, you will see a lot of cars. They're just parked in some area, which is not good. So I think we should go either up or just down. So my connections, they can, of course, be used for high-rise buildings. So that's why we can save more space. We can remove those slums and then make maybe one building which can accommodate more families. Thank you.
Thank you, Dr. John, for that presentation. I want to say that maybe you should consider the cost implication of this research, take it to that level, because cost is very important. It allows you to make rapid decisions with respect to this mobile fabricated shelter. Thank you very much.
Thank you.
Let's appreciate Dr. John. Yes, we are gradually getting to the end of this session, but we have the last presenter is Dr. Taku Kumato from Joseph Taka University, Makurdi in Nigeria. Makurdi is in the northern part of the country. So Dr. Dr. Taku, is going to present a paper on durability evaluation of calcined clay and limestone powder blended ternary self-compacting concrete. So Dr. Taku, you're on.
Thank you very much. I hope to take 10 or 15 minutes for this presentation so that we'll leave more time for the comments. I think that's the beauty of presentations, when you have input and comments. Thank you. So basically, this research was carried out in conjunction with Professors Y.D. Amati, Professor Stephen Pinde-Eje, and Dr. Lawan, who were my PhD supervisors at the Ahmadu Bello University of Nigeria, Zaria, which is also the northern part of the country. And the work is aimed at domesticating self-compacting concrete in Africa. Basically, the concrete we use over here, after we prepare that concrete, we vibrate it. It doesn't compact on its own, we have to compact it. But elsewhere, because of the complexities of buildings, the complexities of the architectural designs that we're getting from architects, the amount of reinforcements is also increasing. And so it's getting more and more difficult to compact certain areas properly. The self-compacting concrete actually began in Japan because of this and the fact that they have less of skilled labor. So, all right. Now, the presentation is going to carry an introduction, the materials and method used for the work, the results, the conclusion. I'll make room for questions. Now, what is self-compacting concrete? It's concrete that is made from normal concrete materials, but without vibration. The concrete is not vibrated externally, but vibrates by its own self-weight. Now, in producing self-compacting concrete, we use a lot of cement it requires a lot of cement and other materials. And so basically, it could increase the CO2 footprint of concrete as well as cost. And therefore, we are looking at how can we make self-compacting concrete production sustainable. It's by use of local and cheaply available materials. We have two types of materials that we can use in self-compacting concrete to increase the powder content. Instead of using only cement, we can use pozzolanic materials, that's supplementary cementitious materials that can be used in partial replacement of cement. These materials are not cementitious in themselves, but when used in the presence of lime and moisture, could produce cementitious properties. So we could use those materials, and then we can also use filler materials, which are not cementitious, but could also improve the properties of concrete. Thereby, in doing that, we have introduced local materials, that's local content, into self-compacting concrete. We could also have reduced cost of producing self-compacting concrete, as well as the environmental effect. Now, that slide talks about some of the importance of self-compacting concrete, which we have mentioned a little of them. Improved pumpability, produces a more uniform concrete surface, amongst other advantages. We've already talked about the problems associated with SCC, which is high cement content, and then environmental effect. And self-compacting concrete, even though it has been used for some time, it doesn't really have standardized mix design yet. So these are some of the problems associated with SCC that this research work had attempted to solve. For this particular paper, it is going to solve the first problem, which is cost, environmental impact, and high cement content. And this problem is going to be solved by the use of SCMs and filler in binary or ternary concrete. Now, binary concrete is where we use cement and one other material to produce concrete. Ternary is when we use cement and two other materials, either an SCM or a filler in concrete work. So in this research work, we used calcined clay produced by NIBRI. NIBRI is Nigeria Building and Road Research Institute. They have produced a pozzolanic material called calcined clay, which is not yet fully in use. We wanted to see how it can fit into our self-compacting concrete. We also made use of limestone powder. The northern part of Nigeria has a lot of limestone, and we produce a lot of cement as well. So this limestone is also already available. How can we use it to also improve on the properties of our self-compacting concrete? The materials used for the research work, we used cement, which was a grade 42.5 N, not R, sorry about that. Fine aggregates, coarse aggregates of maximum size 20 mm. For self-compacting concrete, the maximum aggregate size should not be more than 20 mm. Then we made use of the calcined clay, the limestone powder, and a super plasticizer, which is also a locally produced one, SPR 300, made by a Wafa Group, manufacturing group in Lagos. So basically, we want to see how all the materials we are going to use for our SCC can be found locally to improve on the local content and to reduce the cost of producing self-compacting concrete. The methodology, we characterize the materials for their properties, like the oxide composition of the limestone powder and calcined clay was carried out using XRF analysis. They will also check the structure of these materials using XRD and SEM analysis. The cement was characterized using BS12. The aggregates were characterized using BS812. And then we check the fresh state properties of the self-compacting concrete using, that's to check the flowability and deformability using slump flow test, V-funnel, and then we also use the L-box and the J-ring. These are various equipments that are used to ensure that the SCC in the fresh state meets up with the properties specified in different specifications like FNAC 2005 and the different BS codes that are meant to guide the use and production of self-compacting concrete. At the hardened state, we were concerned with the permeation and strength properties. Basically, permeation gives an idea of durability. we know that ingress of materials in concrete is not a good thing for engineers. And so anything that can be done to reduce the ingress of materials into concrete could also reduce or rather improve the durability of the concrete. So in terms of durability, we check the water absorption and the sorptivity. The difference between the water absorption and sorptivity is that while water absorption look at the overall absorption of water through the various pore spaces holistically, sorptivity look at permeation through capillarity. And sorptivity is actually the most important measure because basically for a continuous pores, if water is able to permeate through continuous pores, then it can get to the reinforcement and cause problems. So if the sorptivity can be improved, then we can also improve the durability of the material. Of course, we looked at the compressive strength, split tensile strength, and then we check the microstructural properties using same FTIR and EDS. The mix design, let me just talk a little on that. A group of researchers, Arobia and others, actually were able to develop mixed design charts for self-compacting concrete using what we call the micromechanical procedure. And so those charts were used in the mixed design for this work. Apart from these charts, normally the mixed design is via trial and error, like it's done in normal concrete. And then you check the properties at the fresh state to see that your mixed design that you've come up with meets up with certain criteria specified in the codes. That shows the quantities for the various, we dealt with 4 different mixes. The one that is stacked 0% CC, that is, we did not use an SCM. We only used calcined clay as a filler. Then the second one, M2, we made use of calcined clay as both filler and SCM. Then the third mix, we made use of limestone powder as filler, but didn't use SCM. And in the fourth mix, we made use of, that is, the first 3 are actually the binary. And then the ternary concrete, we made use of calcined clay as a semi-replacement material, and we made use of limestone powder as the filler material. So the table shows the various materials, the cement, the calcined clay, and the limestone powder. It's interesting to see that calcined clay contains, if you check the silica, alumina, and iron content, is up to 70% put together, which is what STM C618 says should be for a Class C, a Class F pozzolana, which means in terms of oxide composition, the calcined clay meets the specification for a pozzolana. The by chart there shows that more than 50% of calcined clay is actually contains a kaolinite, or which is a silica-based material. That's the XRG. We can see that the peaks, the peaks we see there, the major peaks there are actually peaks of silica, which means it's a good material, a pozzolanic material rather. That is for the limestone powder. The next one is for the limestone powder. The peaks are peaks of calcite, which means that limestone contains more of calcite. It's not pozzolanic, but because of its calcite content, it can also improve the microstructural properties of concrete. Okay, that's that one. This is the chart, which shows that it contains up to 80% of calcite, and the remaining ones are the few clay minerals. According to Liu and Yan, the limestone powder is not pozzolanic and remains unhydrated even at 28 days. However, if the filler effect of limestone powder is combined with the pozzolanic effect of calcined clay, it should improve the cement paste matrix as well as the interfacial transition zone between the matrix and the aggregates, which will improve the overall performance of the concrete. That shows the fresh state properties. The mix that was carried out for the 4 SEC produced all met the specifications of FNAC 2005 for the fresh state properties of self-compacting concrete. This one shows the filling and passing ability using the L box and the J ring. Okay, this shows the water absorption for the different mixes. And in all cases, you can see that the water absorption decreases with age, which means that as the concrete ages, as hydration takes place, as the post reaction also takes place, the pore spaces are filled up with the products of hydration, thereby giving us a better and improved concrete. The same thing applies to the subtivity with the mix with 50% calcined clay and using limestone powder, producing the best subtivity result. Of course, subtivity also decreases with age, which means as it ages, we have better permeation performance from the concrete. The strength at the different replacement levels also improve with age, with the 15C, that is the one containing 50% calcined clay, and using limestone powder, showing better strength development with age up to 56 days curing. That is for the split tensile strength. We have the same pattern as that of the compressive strength. Now, basically, we want to see concrete with a denser microstructure, reduced pore presence, as well as improved products of hydration. That is what we're looking for in our microstructure analysis. That shows the result of SCM with EDS. The first one by the left is for when we use calcined clay as mineral filler. The second one is when we use limestone powder as mineral filler without using an SCM. Why? Oh, sorry. Okay. We see that when we use limestone powder as filler and don't use any semi-replacement material, we have more pore spaces because there's no post-Atlantic reaction there. But as we can see, the last picture by image by the right shows the ternary blend, which actually gave us the best microstructural look, both in terms of how dense the material is, as well as products of hydration. So we can conclude from this research that calcined clay and limestone powder meets the specifications for a good pozzolana and mineral filler, respectively, due to its oxide composition, fine particle size, and filler effect. Also, the properties in the fresh state investigated were all within the specifications of the various codes. However, the ternary ACC showed better flow and viscosity characteristics. The durability performance of the ternary ACC was also better than that of just the binary, as well as the strength and durability. The microstructural properties were also improved. It is recommended that if we want to produce self-compacting concrete locally, we should use 15% replacement of cement with calcined clay and use limestone powder as mineral filler. I also want to state here that even though it's not part of this work, the next phase of this work, we also try to see how we can further improve the microstructural properties of this calcined clay by incorporating MICB, that's microbial-induced calcine precipitation technology, into self-compacting concrete, so as to further improve it for domestication in our region in Africa. Thank you for listening.
Thank you, Dr. Taku. It is now question time. How many of us have questions for Dr. Taku? Yes, I want to know the number of people before we start. Once we start, there will be no room to take in more questions. How many people have questions for Dr. Taku? I can only see one hand raised. Just one person. Do we have any on the virtual mode? IT, Do you have questions? Not yet? Okay. Okay, let's start with Dr. Labiron.
Okay, thank you for the presentation. Now, you mentioned that you used OPC, but that's SEM1, and nobody makes SEM1 again. However, if you said SEM2, what is available locally in Nigeria is BL. And BL means that 33% is limestone powder. That BL means that up to 33% of that cement is made of limestone. The remaining 70 or 67% is OPC because of the Paris Accord. Now, my question is, did you consider the limestone in the SEM2 that you used as additional to, because you're only showing limestone powder, did you consider that content? That's question number one. Question number two, pozzolanic effect is about digesting calcium hydroxide that is in the hydrated products due to the cement hydration. And at the end of the day, it would be nice for you to find out how much calcium hydroxide is generated per kilo of cement in hydration. That would help to now nail down on how much percent replacement that you need. The other thing I wanted to ask is that usually supplementary cementitious material kicks in after 28 days and up to 91 days. But I can see we are mentioning 28 days. Yes, you mentioned 56 days, but that's really when it starts. And it can still continue for 91 days. There are even results for 250 days. And then the last thing is that we have kaolinite clay. We saw some as we were coming up here from Kigali. It's all over Africa. We're blessed with it. The question now is that why are you not looking at making your own calcined clay? How would you be interested? Because there are other direct tests apart from XRD. We don't have X-ray refraction or X-ray diffraction machines available. But there are other tests which you can run that would give you a measure of pozzolanity, which means you can actually take clay from Muzanze here, fire it, and test to know whether it's pozzolanic. This is just a suggestion, but mine is that did you consider the limestone in the cement already? The inert limestone, did you consider it in your work? Thank you.
All right. Thank you very much. These are wonderful contributions as well as questions. I know that you're a materials man, so I was looking forward to that. Actually, I didn't use OPC. That was a mistake. It was PLC, like you have said. Most of the countries that have signed the Paris Accord are trying to see how they can reduce clinker. That instead of using the whole cement to be a calcined limestone, which is calcined at a temperature of 1,000 degrees and could contribute to global warming, they have agreed that instead of calcining all the limestone used in cement, a part of it from 5 to 30%, depending on which cement you use, is actually put in as raw limestone. So actually, and that is the point. Now, in the work, basically, self-compacting concrete requires a lot of fines. Because of the time frame, I didn't go into the composition, but if you see the quartz aggregate content is reduced, and the fines content is increased. And so, whether it's limestone or some other material that are used, it is able to increase the fines content in the cement, in the concrete generally. And because limestone is inert, it's not pozzolanic, it's not really going to impact on the cement hydration, even if we bring in extra limestone into the concrete mix. in terms of the pozzolanic activity, yes, kaolinite is a very good raw material for making a pozzolana or a ACM. Most research has been carried out where kaolinite, when it is calcined at between 500 degrees and about 800 degrees, actually produces metakaolin, which has been used extensively in concrete, in research in concrete as ACM, in partial replacement of cement. So yes, it's possible to make use of the kaolinites we have locally. Why we're using already produced calcined clay is that NIBRI, a federal government agency in Nigeria, is saddled with improving local content in construction. They have made this calcined clay already. It is there. It now beholds on us as researchers to see how we can make use of this, which are already produced. That is why instead of going to pick kaolin clay, which is also available in the northern part of Nigeria in large quantities, I chose to use the one that they already produced. It's a way of trying to see how viable this their construction material that I produce could be in our experimentation, and perhaps in industrial usage as well. And then the other question was, can you come with the last question?
And would you like to look for a more direct method of knowing how much pozzolanity?
Okay. Now,
because you see, you are not sure of the pozzolanic index.
I understand. The earlier part of this research, which I presented at Akure, at the engineering conference in Akure, we actually made use of this limestone powder. Sorry, not limestone, calcined clay. Replacement level at 0, 5, 10, 15, 20, down to 30. And so by replacing in different percentages, we picked the one that gave us the best result in terms of the strength and in terms of the durability characteristics that we measured in terms of permeability. So yes, there are different measures of pozzolanity, but in this case, we actually replaced the percentages, and the optima was the 50%, which we used in this research. That's how we arrived at the 50% for this research.
Thank you, Dr. Taku. Let's have a question.
I think I still have time.
Yes, no.
Okay.
There are more questions. I want to take the one that is posted. Okay. The ITP. Do we have questions on the virtual platform? Okay, okay, Prof. Questions? There is still time. Okay, Dr. John.
Thank you very much. You know, as I know, like when you are developing something, let's say new, you are making your new mix design, right? And you are making, of course, you are mixing something which is new to see whether they can work or not. So the question is, so what is the controlling mix design? Or like what I want to see, the deviation of your results to the existing mixing design. So yeah, the controlling specimen, if you can say like that.
Okay, if I understand that question very well, like your normal concrete.
Yes.
We know that if you mix 124, for instance, to give you a particular strength. Of course, like in my discussion with Dr. Wale when we're coming, the use of limestone Portland cement, with the use of limestone Portland cement, even that now, you cannot really be sure that if you use 124 now, you are going to get that particular strength that we used to get before now. So even with normal concrete, we need to carry out trial mixes to be sure that our mix is going to give us a particular strength that we want. The difference between self-compacting concrete and normal concrete is that in terms of self-compacting concrete, the quantity of quartz aggregate is reduced. The amount of fines is also is increased. And so the basic mix design method for SCC is that you carry out mix design based on the normal concrete. For instance, if I want a strength of 30, of grade 30, I carry the normal mix design for grade 30. And then I now start adjusting my constituents. I adjust the quartz aggregate content, adjust the fine aggregate content within specified limits. If you look at the codes of practice for SCC, there are specified limits within which you adjust. I'll make these adjustments and then carry out a trial mix. If it doesn't work out, you still make other adjustments. And that's the basic problem with self-compacting concrete, because we don't have a particular mix design, standardized mix design. These are the kind of adjustments that we'll carry out. However, like I said, a group of researchers have tried to come up with design charts. Those design charts were based on a principle developed by Professor Kari Halor that is based on what we call micromechanical properties, whereby you look at the what do you call it, the rheology of the pest, and then you develop the rheology of the concrete from that of the pest, and they use that to carry out mix design using thousands of specimens. They did simulation and came up with design charts. With the design charts that they have come up with now, the level of trial and error is reduced. There's still going to be trial and error, but with the level of design charts, if I want a strength of so and so, I can simply go to the chart, check based on the pest properties that I want, pick the constituent materials, and now do mix design, prepare my mix based on what is in the charts. That way, the deviations will no longer be too much, and so the amount of trial and errors are basically reduced.
Okay, so so during the changing of those ratio, let's say portion, okay, so so what was the constant? Or you change, you know, sometimes if you change three things at the same time, now it's very difficult to come up with the right conclusion.
Okay, it's also a function of the mix design method you adopt. There are different mix design methods. The empirical mix design method, the Japanese method, there are different methods for mix design of SCC. So what is kept constant basically is a function of which mix design method that you use. In most cases, you keep of course, the cement is constant, the water these are constant. What we are actually tinkering with is the fine content and the quartz aggregate content. That is most times that's what we play with in self-compacting concrete. I don't know whether that sticks to your question.
Thanks.
Control in terms of sorry? Okay, control mix in terms of, okay.
You didn't have any pozzolanity.
Yeah, that was mix one. Mix one didn't have any pozzolanity, but it also contained just a filler material, but no pozzolanic material.
Let me just help you. His first mix did not have any calcined clay. That was his control. So what he's asking you is that you are supposed to now report how that performed to all the others, keeping it as control.
Okay, okay.
Because all this, the Japanese style and so on, they will give you a starting mix, which, of course, you must express in kilogram per cubic meter. And that's the language everybody will understand it from FNAC.
Sure.
So, but as he's saying, your control from what you showed, I think is your mix
It was
one.
M1,
You
that's
didn't have any addition of kaolin or calcium clay, so to say.
Thank you for that.
Okay.
Thank you very much. This brings us to the end of the presentation, but there's still, please let's appreciate ourselves. Thank you for all the presenters. And there's still one thing left. I don't know whether Dr. Francois wants to handle that. The Deputy Vice Chancellor, Academics and Research. If you want to clap.
Invited guests, such as an expert from across the continent, distinguished delegates, ladies and gentlemen, wishing you a good afternoon, sorry, a good evening, and a good stay at Ines Ruhengeri. I'm very honored and delighted to deliver the closing remarks on the International Conference on Civil Engineering Education in Rwanda 2021. On behalf of conference organizers, I would like to express my gratitude to all of you who have come together here from various countries. Your cooperation made this event to happen today. Today we have, nourished by different researchers, brilliant presentation in various engineering fields, and hope it boosted us with knowledge that will help us to improve applications of new knowledge in the field of civil engineering. My warm appreciation goes to Dr. Francois and his team for their sacrifice, efforts, and time invested to organize this important event. Our gratitude goes to different stakeholders, including the University of Aberdeen, UK, the University of Ibadan, Nigeria, the Catholic University of Cameroon, and the University of Botswana for their cooperation while organizing this grateful event today. We thank you for your important cooperation, and Ines will keep remembering your academic brotherhood that you have shown us today. The conference is expected to be the platform for researchers across the African continent to discuss challenges and opportunities in civil engineering with the ultimate goals to reposition the education in this area in line with the UN SDGs for quality education. The conference is also expected to be an opportunity for researchers to build new partnerships for sustainable development in line with UN SDGs 17. This conference is a result of a project strengthening academia to industry, linkage and research space in the area of civil engineering for food security in sub-Saharan Africa. The implementation of this project runs from September 2019 to January 2022 in collaboration with the mentioned universities, including University of Ibadan, Nigeria, Catholic University of Cameroon, University of Aberdeen, UK, and the University of Botswana, Southern region of Africa. We are happy that you have been ready to partner with us since the application of this project until we succeed, and then together for this important event that really contributed to many of us, especially people specialized in civil engineering. But of course, ourselves, we learned much from the discussion. It is my hope that this conference will enable us to build a strong partnership that will lead us to respond to various challenges facing civil engineering fields across the continent. This is the end of the first day of this conference, and I seize this opportunity to express my thanksgiving again to different stakeholders who participated in this project, and officially declare the day one of this event closed. And invite you once again to tomorrow's event as scheduled on the plan of this conference. I wish you a very pleasant evening. Thank you.
Thank you, sir. The DVC has declared the first day of the conference closed. But I want to try my language again. Ni ahejo. See you tomorrow. Did I get it right? Okay, so see you tomorrow. Ni ahejo. Then muramuke. Good night.